Okay, I think we're live. I'm just using my phone to check if we're actually live. So, welcome, everyone. Yeah, I think we're live. I can just keep this on for the chat. Okay. Alright, well, we'll probably keep this going for 2 hours-ish, maybe an hour. We'll see how it goes. I think it's working, so I don't think we have a thumbnail. We'll just keep that as our thumbnail. It should be fine. I'm gonna be looking at my phone a lot, so apologies. Okay, well, we can get started. Okay, what I was thinking of doing is simply going over all of the notes that I had with my teacher for AP Calc BC, starting from Unit 1 to Unit 10, so we'll kind of speedrun them because I'm hoping you already know them. I might actually keep the chat on my phone, if that's okay. I'm gonna keep the chat open on my phone. And yeah, I'll have someone moderate the chat actually. Related rates, we'll get there. We'll get to related rates. Yeah, that one's kind of a hard topic. It may or may not appear on the test. It will most likely be an MCQ. I can't see it being really an FRQ. But it can be an FRQ, so we gotta keep that in mind. Okay. Everyone can hear me okay? Is this okay sound? I have a laundry working in the background, so yeah, I got responsibilities around here. Okay. Okay, I'll just pause this. Okay, you should be able to see my screen. Okay, well, first unit is limits. Limits are pretty easy. Not that bad. You should know the basics of limits if you're this far in calc. If you still don't know limits, you're cooked. So yeah, just approaching limits at infinity, easy. One-sided limits, just look out for the symbols, know from which side it's approaching from. Limit existence, yes, pretty easy, left, right. Value versus limit, they're not the same. For example, if there's a hole here, the limit is different from what it's actually defined at, so just keep that in mind. Close versus open, yes. Holes versus simply defined at that point as well. Jumps, yeah, sometimes they're defined at that point, sometimes they're not. Two-sided limits exist for both, but the limit in general at that point does not exist. So okay, I hope optimization never shows up either. It might as an MCQ, so just gotta keep that in mind. And behavior, asymptotes, yes, just the good thing about calculus BC is you don't need to know if it's negative infinity or positive infinity in terms of limit. You can just say it does not exist, which is kind of convenient. Rationalization, I guess it's good to know. Do you know how to rationalize the denominator? Because sometimes it'll give you the right. Oh my god, so many. Go product groups. Okay, I will. I'm going through beginning to end. We'll make through everything for calc by the end of it. Yes, I'm going over everything. I'll go over everything. So rationalizing the denominator, sometimes you have to do it. Most of the time, I'll hope that will be your move, but if you feel like rationalizing is faster and is more effective, you can choose to do it that way. Analytically, pretty easy. There's several conditions. Direct sub, if it usually gives you a real number answer, that'll probably be your limit. Sometimes it works, sometimes it doesn't. Piecewise, this one's kind of tough. If it approaches from negative, use the less than x, and if it approaches from the positive, use the greater than x. If those two values are not the same, limit does not exist when you plug in 2 for both of these, because that's where they kind of change. If it's the same value, there's a limit at that point. If it isn't, then there's probably no limit. Okay, 0 divided by anything 0. Anything divided by 0 is undefined. Anything by itself, this is pretty easy. Intermediate forms, be careful, you can't just assume that's 0. I'll go over everything, just give me time, that's all I need. Okay, yes. I'm hoping you guys can still hear me. So, number over 0, limit does not exist. 0 over 0, infinity over infinity, keep going, there's several stuff we'll be going over. Infinity minus infinity, that one's hard. I didn't even review that one. This is a direct sub. This is a presence of a whole. If you plug in 4, you get 0 over 0. But if you actually factor, you can see there's a whole at x equals 4, and then you can actually get your limit. Plus h problems, we'll get to that when we get to the derivative definition of limit. Or limit definition of derivative is what I meant to say. More rationalization, pretty easy. Fractions, yeah, just get them common in denominator and make sure to simplify it as much as possible to find your limit. Absolute values, the limit at absolute value where it changes from negative to positive is most likely going to be does not exist because there's a big jump. So just keep that in mind. Absolute value could come up. Yes. What's the Fortnite quote of the day? Bro, I do not have a Fortnite quote of the day at the moment. I'm so tired. Okay. I'll have one probably by the end of the stream, trust. So practice. Okay. This more, we'll get to this. It's just a limit definition of derivative. But this actually simply, what is it? Since h is approaching 0, you just have to apply the concept of plugging it in its direct sub, and you should be able to simply rationalize, I believe, here, right? Because this is not, because at this point we didn't learn about derivatives or anything like that yet, so, but don't worry about that, we know derivatives. Limit, yap. Okay, more of this, just know how to look at the graph and know what the limit is, whether it does not exist or is, yeah. So for infinities, negative or positive, you can just put D and E, which is kind of convenient. Algebra is your first move for intermediate forms. So yeah, factoring, rationalizing, other form of algebra, reassembling your expression to find the limit. But FEPL is another good approach. FEPL is your factorial, which is, well, you may have learned factorials if you're this far in Calc BC because they come up a lot in series. AB not so much. Factorial is a number times its next lowest number, and the sequence keeps going until 1 is reached. So it's like 5 times 4 times 3 times 2. You should learn in algebra. If you didn't, now you know. These tend to increase the fastest. Exponential is the next fastest, and then polynomial power is slower than exponential in terms of increasing, and log in terms of natural log of x or like log base of anything else, it tend to decrease slower than the rest. FEPL, try to remember it. It comes up sometimes. So here you can see x squared increases slower than e to the x because this is the p in FEPL and this is the e is higher, so it increases faster, so the limit will be 0. For negative infinity, those one will be d and e because it's it's infinity times e to the infinity, which is just d and e. Here it's simple, it's direct sub, x squared FEP p increases faster than FEPL o, so hello Yuyi-san. So yeah, x squared increases faster than the log, so it'll be d and e. And for one-sided limits, I guess this one you just have to visualize it sort of, but it'll be 0. So yeah, limits, I mean, it's not bad, just know your FEPL. Flowchart, there's also what matters most. That's also convenient. So key thing, FEPL is when x is approaching infinity, whereas what matters most can be used for both as x approaches positive and negative infinity. It's useful because what matters most, you can just take the whatever is actually impacting the numerator and denominator. So here cosine x is going to be a very small number. At the end of the day, it just cycles between -1 and 1. Oh, you gotta, okay, I'll go over product rule right now. It's pretty easy. Let me go to unit 2. I think it's in unit 2, right? I mean, that's when we did all the derivative. Let me quickly find it. I got you. Notation, product power rule. Okay, that's useless. Okay, product rule. Okay, so basically the idea of product rule is when you have two terms being multiplied and you want to take derivative of it, you take the derivative of first and keep the other one constant, and then you plus the derivative of the other one times keeping the other one constant. So here's an example with x to the 7th times sine of x, where the derivative of that would be you keep x to the 7th the same, and then derivative of sine is cosine, so multiply those together, plus now you're taking the derivative of the other term, so it's 7x to the 6th times sine of x, because we're keeping sine of x constant. This is not how you should do it. Remember, yeah, it's not that bad. Yeah, so I don't know, product rule, kind of easy. Extended product rule, I guess it's good to know. It doesn't come up a lot, but you could just do it with 3 terms, just having 3 terms added together instead of 2, and taking the derivative of individual one and keeping the other 2 constant when multiplying. So here's an example. I'll get back to this, but this should be the basics of product rule. Extended product rule, yeah. Okay, back to unit 1. Hopefully that helps. Yeah, no problem. KFC Zinger box. Okay, what matters most? I feel like what matters most, here's a good example. Do I need to know cotangent secant derivatives for the AP? Yes, I believe you do. I guess I could go back and quickly go over those. Right? Physics C mechanics, I don't take that, so we're not going to go over that. Sorry. Wait, could you do logs and exponential derivatives? You should have all derivatives and integrals unlock. Yeah, honestly, you should be familiar. Should not be struggling. Well, okay. I mean, not everyone is as ready. Everyone's struggling. I might forget some easy rules tomorrow, but... Oh, wait. And you have a test tomorrow? Wait. Just started Calc? When you start self-studying it, I mean... Yeah, okay. Or are you like self-studying? Do you have the exam tomorrow, or are you just prepping for next year? Physics 2. Oh my god, yo. Keyboard, man. I did not even start studying for Physics 2. I'm cooked for that. That sounds like an after Calc issue. AP CSP King. That's after Calc issue. Come on, we need... That's... Yeah. I'm cooked for those classes. I'm just focusing on Calc right now. Back to unit 1. What matters most? Pretty easy. You have x squared minus 3x plus 2 and 2x squared. You just look at what matters most, right? So x squared cancel out. You have the limit is 1/2. Pretty easy. If you know your asymptotes, you can also say that it's 1/2 because that's going to be your y equals 1/2 as your asymptote. AP pre-calc, I'm not going over that shitty course. Zinger box, CKX, and the derivative. Yeah, okay. Yeah, that's the derivative definitions of some... Yeah, that's e to the kx. Wait, is that right? Yeah, that's probably right. Yeah, what matters most? Pretty easy. Just look at your leading coefficients and from Jakarta. You're not from Indonesia. Conflict. Yeah, have a nice day, you too. So rest well. If you have the exam tomorrow, good luck. Here you just take what matters most, square root it, so it's 2x over x, which is just 2. Oh, I guess it's absolute value. That's another cool thing to consider. Good thing to consider. So it's -2. YouTube might not be... Yeah, okay, I'm sorry. I did not curse, guys. I said hit. Trust. For plus side, I guess some of these you have to visualize, especially one-sided limits. Or you could approach it algebraically, but that's kind of hard. Let's see what is... Okay, you're just rationalizing, factoring. And then you plug in 4 and you get 0. Okay. Oh god, so many comments. Let me read all these. Could you continuity? Yeah, I'm getting to that. How long will this be? Probably 2 hours, maybe an hour. We'll see. As I'll hope it does. Limits seem very tempting if limit x equals... Yeah, I know. AP Pre-Calc review. I don't take that class. I'm cooked for... I mean, thank God, because I think AP Pre-Calc is harder than Calc BC. And AP CSP. Hello, Mr. P. What's up, Vidong? CSP's D is just AP. Shut up. It kind of is. I agree. Are you done with AP Calc? Done? Not yet. I still have a little bit more studying to do. Okay, let's move on. Hopefully you can still see my screen. Okay, we know all this. Algebra. What matters most and FEPL for infinity over infinity. 2 hours? Yeah, probably. We'll see. Okay, when it's infinity minus infinity, you just want to combine the terms and look at one sort of term to work with for the limit. So those ones I haven't been working a lot with. Unlikely to show up. Just know your FEPL and what matters most. The trig identity, like, I feel like those questions don't really test and more just memorization. They do. Calc, like, what College Board is also testing with Calc is memorization in general. There's no formula sheet, which means you're basically required to memorize everything in terms of convergence and convergent tests and all the rules, integral rules, derivative rules. So they do test your memorization. Yeah, it's not just can you apply the math, it's also can you remember it, which is kind of a, hey, there we go, we got to continuity because someone asked about that. It's pretty easy. It's I don't know what's happening here. Function f is continuous at point x if and only if. Okay, so the limit has to exist at that point. Obvious, meaning that the meaning that the limit from the left side and the right side is the same. F of c is defined, and the limit as x approaches c of x has to equal f of c. So it can be like a hole with a point defined at something else at that point. I've never seen. There's a. I've never seen that. Number over infinity. Yeah, that's 0. Okay. Anything over infinity is 0 because it's too big at the bottom, which basically converges to 0. Type of discontinuities. Removable, whole. That's the main one. Non-removable. Removable limit exists. Oh, I just realized that. Okay. But non-removable limit does not exist, which could include jumps, where it just changes graphs at that point. Most likely a piecewise. Limit DNE for vertical asymptote. Infinite discontinuity is another name for it. And some other weird scenario, which purely depends on what graph or equation you're working with. Continuity, continuous. Yeah, this is just graph analysis. Shouldn't be that bad. Please come to I'm not going to Cambodia, bro. Continuity of the equation. You're not even from Cambodia. On YT. So just if the y values are equal with the closed dot. Yes, basically that's exactly it. So just if the y values are equal with the closed dot. Yeah, if the left limit and the right limit are equal, then the limit exists. And if the actual point defined at that point is also equal to the limit, then it's continuous. It's kind of logical. Once you work a lot with limits, you kind of get it. If you're struggling with this, do try to look for some limit help or limit practice MCQs and FRQs out there. I can't go over every single topic in terms of MCQ and FRQ, so I'm just covering like the content itself, and then I'm hoping you can apply it tomorrow as needed. Continuity of that, yeah, I'm not doing all that. That looks like a lot of issues, but it's kind of easy. You could see it just splits cosine and sine, and then you could just look at when the numerator and denominator specifically, is equal to 0, in which case that's a vertical asymptote, and then you could talk about that as non-removable, or yeah. So trig, not my favorite, but it exists. Piecewise, not bad. Just compare your two-sided limits. F of -2 does not exist, key thing, even though the limit may exist. Yeah, the limit may exist, but it's not defined at that point because there's no less than or equal to. So, yeah. Okay. I am not answering that. Why are y'all calling me? Okay. Honestly, the limits units just feels like algebra. It is. See, that's the thing about limits. Limits, like we covered them in pre-calc at the end of the year. Obviously, like once we finished the rest of the content, it was like calc preparation. And yeah, it's honestly a pre-calc. The thing about calc is it actually applies to like derivatives or whatnot and actually covers them officially. So make continues, not bad. Honestly, this is pretty easy. We're finished with limits. We'll call it a day. Shoot, I should probably get some water. I might have to leave for a second to get some water. Unit 2. We'll go back all the way up. Okay, tangent secant lines, not bad. Secant touches 2 points, tangent touches at 1 point. More comments? Okay. We do get the paper to do the problem, yes. Yeah, it's most likely the FRQ layout is question, sub-question, little area to do it, sub-question, little area to do it, sub-question, little area to do it. And try not to write outside the box or they won't grade that part. And if you write like an important piece of your equation or answer outside the box, you're cooked. You can't do that because then they're not gonna see your full solution, and that may involve some sig figs. Any calculator tips for the calculator portion of the test? I have some actually. I might grab my calculator if you give me a second. I don't want to waste my battery though. I'm hoping my calculator will last till tomorrow. I'm gonna risk it and not change my batteries. So, okay, let's see. I'll probably have to clear some of these graphs as well. You also have to learn how to use graphing calculator. Yeah, okay. So, one key thing I learned is, let's go to function mode. Oh god, I have too many functions here. We'll just keep this complex function. I don't know if you can see it, it's pretty long. Graph. It'll grab the function. And the thing I noticed, when you specifically are looking for intersection between 2 points, or between 2 graphs, let's say, we could do, let's say 20, or not 20, that's too big, let's do 5. So let's say we're looking for intersection between that. The concept, okay. Yeah, I'm good for tomorrow. What is AP Calc? I don't think AP Calc is happening. Sorry, little bro. What piano? Wait, guys. Wait, why'd I? Okay, anyway. Okay, anyway. So if you're trying to look for intersection, you could click second calc and like 5. It depends on your calculator. I'm using TI-84 Plus. You could just like click right, but that's not always effective because as you're doing it, it might like slow down at some points. Another effective method to skip through the graph faster is click second and arrow, which sort of like shoots you faster through the graph at each, like per click. So it, I guess, is more effective if you're trying to get through your graph faster to find an intersection at a certain point. So second and arrow to look for intersections is a good approach. To also find intersections, you could click second and calc, and then you could click 5 to intersect, and then you just select your 2 graphs where you want the intersection close to, and then there you could just find your intersection, whatever value you're looking for. That's one calc tip. Another, store your variables. For example, you may have an intersection, second calc 5. Let's find an intersection here. It gives a value 3.351. You could click second quit, store right here. Alpha, any of these green letters you can store your variable as, let's say b. Now you have b defined, and let's say you want to find the integral from 0 to b, and then you could just put alpha f4, your function dx, you're doing it with respect to x, and then it'll just find you your area. Yeah, see, just from that point to that. So I guess storing variables and using them is very effective. That's all calculator tips for now. Okay, let me see if I missed anything in the chat. Okay, what do you think particle motion is going to be? Particle motion, see, the thing is, particle motion usually involves parametric. It usually likes to do xt, yt. We don't know next year. I mean, not next year, we're this year, tomorrow. We may either have a polar or a parametric. If you struggle with parametric, pray you have polar, and vice versa. I'm hoping for a polar because I like a little challenge, and parametric, I tried a practice FRQ yesterday. It was kind of tough for me for whatever reason. So we don't know. It's either a parametric or polar. It's unlikely to be both of them. So anyway, moving on. Derivative of function, slope of tangent line at that point. Different notations, doesn't matter. Limit definition, okay, this one's kind of important. So as x approaches 2 of f of x minus f of 2 over x minus 2. So obviously this is going to be 0 over 0, but this is the limit definition of a derivative, and it kind of makes sense. You're decreasing the x distance between the 2 points of a secant and the y distance to the point where you're actually making the tangent line. So that's another way of thinking of it. I'll probably show some practice problems. Another definition, traditional, limit as h approaches 0. Again, you can see it's going to be 0 over 0 naturally, but it is how you would structure the traditional limit definition of a derivative at a certain point. In this case 2, you usually look at this number or this number for what the derivative is evaluated at. Easy, sign of derivative, what it means. I'm hoping you guys know that. If the derivative is undefined, most likely a hole, vertical asymptote, jump. Another thing is cusp or corner, which is most obvious with absolute values and other weird graphs. Vertical tangent lines as well. Okay, yeah, this is pretty easy. It's just understanding derivative and what it means. Okay, and second, derivative relationship between f prime and f double prime. It's not that hard. Okay, dy dt, dx dt for speed, and the slope is just dx dt. Yeah, that you are right, son. That is correct. In terms of parametric, it does not get harder than that. Only if it's like for the d2y dx squared. Did I say that right? I think I did. Yeah, d2y dx squared, in which case you would do the derivative of dy dx and then put it and then divide it by dx dt. So most people tend to forget putting it over dx dt, but we're gonna go over that. I'm not gonna go too in depth of this. This is pretty basics. It's just f prime positive, f is increasing, f prime negative decreasing, f prime 0 horizontal tangent, concavity, f prime is increasing, f concave up, decreasing, f is concave down, neither concave up or concave down, unknown behavior. So okay, if there's a jump, there's a cusp. If there's a vertical asymptote, vertical tangent line. I'm taking BC and I have not taken AB. A lot of people in my school jump straight to BC. Well, some still do take AB, so I gotta say BC is easier than AB. AB dives way too in depth on the topics, so I might have to grab some water after this unit. So before we're jumping into unit 3, I might have to step out. Curve sketching, pretty easy. Just analyze your graphs and make sure not to mess up. Read properly the question. That apostrophe on f prime is easy to miss on some MCQs, and then you might be thinking you're looking at the right graph, but the answer choice is completely different. And they're gonna include a graph that goes with your reasoning. Incorrect reasoning, obviously, because they want to throw you off, but keep an eye on the question, whether it's a graph of f or f prime or f double prime. So that's pretty easy. AP Pre-Calc, why would you? I mean, we have a video on it. You'll probably find it on our channel. But it's an okay course if the school pays for your exam. You don't even have to buy. If you're self-paying the exams, don't even bother paying for the exam. Just take the class to prepare yourself for calc. Okay, this is just all practice. Why am I going over this? Okay, notation. We don't need to know this. Oh, the rules. Okay. Okay, basic power rule, guys. Drop the power, subtract 1 from top. The derivative of x to the 7, 7x to the 6. Pretty easy. Or there's the limit definition, which is kind of odd, but yeah, integrals are definitely showing up on the FRQs. My prediction, actually, I'm gonna leave my predictions for the end on what the FRQs might be on. Derivative of constant is 0, so just know that, which makes sense. Y equals 4. It's just a straight line. What's the slope changing? It doesn't, so it's 0. What's the slope of it? Yeah, it's 0. Derivative of sine is cosine, but derivative of cosine is negative sine. Know that. Constant multiple, bring it to the front, don't worry about it. Let's take the derivative of what actually matters, leave the multiple of constant ahead. So derivative of 4 sine is just 4 cosine. General power, bring the constant forward, and then just do the power rule that we already covered. This is just the ones with weird exponents. So 1/2 drops down, 1/2 minus 1 is negative 1/2, so it becomes 1/2 square root of x. AP Spanish lit exists because AP English lit exists, so I guess it's somewhat inclusive. Yes, Yi's son is right. Well, I didn't get to e to the x yet, but he is right that e to a constant, the derivative of that is 0, because e to a constant is it's just a number. So and the derivative of a number is 0. So if it's e to the x or e to the 2x or e to the x squared, then it would actually change. But e to 1 power or e to the 3rd power is just a constant. So when do you know when you have to okay, to do chain rule? I'll get to chain rule as well. Rewriting power rule there, e to the x is e to the x, kind of convenient, very easy, unless it's chain rule, so which I'll cover in a second. Slope of the line tangent, actually chain rule doesn't come up until unit 3, so I'll have to hold off on that until my break. Slope of the line tangent to the graph of f at x equals a, that's pretty easy, it's just f prime. Take derivative and you find your slope. So the derivative of this is 6x plus 2. Plug in your 2, which is what you want to find the slope at, and you see that it's 14. So the slope of the tangent line at x equals 2 is 14. Okay. Point slope. important formula to know. Y minus whatever your coordinate of tangency is, y minus your y coordinate of that point of tangency is equal to f prime at whatever that point is. So basically your slope of the tangent line times x minus whatever your x coordinate of the point of tangency is, I guess, is the way to phrase it. And here's an example if you want to look at it while I read these. I'm in 11th grade, junior, so is the other Mr. AP. Yes, Eden Hill is right, you're technically using chain rule for every single one. However, like if we go back to e to the x, you are using chain rule. E to the x is just, well, e to the x, but then you multiply it by the derivative of the inside, but derivative of x is just 1, so it's e to the x times 1, which is e to the x. You're naturally doing it, it's just you're not conscious of it, sort of, or you're just not as considerate of it. Yeah, always use point slope. Point slope comes in handy. Horizontal tangent lines, pretty easy. Take your derivative. This one's kind of tough. No, it's not. Can we find derivative? Okay, I'll get to that. Back to limits. What is going on here? Okay, not to worry about it. Warm up. Tangent lines. Normal lines. Not talked a lot about, but normal lines. Oh, I forgot to cover something for limits. I'll have to go back and do that. Normal lines are lines perpendicular to the tangent, which is, well, negative reciprocal of the slope at tangent, but the same point. So for point slope, you just change the slope. Bro said, am I the only one? Nah, bro, there's two of us. Okay. Normal line, opposite reciprocal. Yeah, just know that it changes. And, yeah. Am I the only one? Yes, I created the channel, sure, but I couldn't run it alone. Derivative. Product rule. I covered this. Extended, covered. Quotient. Okay. Okay. How do you find the slope of a linear line? How did you do it like back in middle school? You could just do your 2y coordinates. The slope is not changing. So the derivative would actually be a straight line for the entirety of that whatever function of a linear graph is, because the slope is not changing, but it is constant. Hold on. Okay, so that's how you find the slope of a linear line. Grab 2 points and then do your change in y over change in x. Okay, so I should always, okay, well, to be safe, yes, but sometimes it's just like implied. You might waste time by like thinking of, okay, time to use chain rule when it's just the x that's you're working with. So I wouldn't really like worry about chain rule, but if you want to for security measures, yes, go ahead and use chain rule for everything. Normal lines for AP Calc BC. Maybe. I did not see them come up that often, but they might. Actually, you know what I'm gonna do? I'm gonna quickly check the AP Calculus BC course and exam description for 2024. I think. I'm gonna quickly double check your. Okay. Shoot. Did you, okay, got so many questions. Did you take my SAT? No, but the other Mr. AP did. Shadow is usually just the slope of x. Yeah, that's easy. Sending love from Shibuya. Okay, buddy. Or rise over run. Yes. Can you run through El Hospital's rule? I will in a second. Do you any Calc AP mock tests? You can Google them and probably find them. Can we go over slope fields if possible? We will in Unit 7. Can you keep the stream up after it's over? I'll try, I guess. I mean, I got other stuff to do, but I guess I could. Normal lines. Hold on the course and exam description for calculus AB, I'm reading for AB and BC, I guess. It says questions could include find the average rate of change on an interval, instantaneous rate of change at a point, derivative as a function, derivative value at a point, or equations for tangent or normal lines at a point. So I guess actually, this is for sample instructional activities. That is the only place normal lines are mentioned. So, I don't know, take that with a grain of salt. I see your comment. Calc AB mock tests. You can Google them. I can't really screen share, but actually I might be able to. AP Calc. No, it's fine. Just you can Google them. Type into Google search. Do you know? I mean, like AP Calc, AB practice test, and you should be able to find full PDFs with answer keys and effort keys at the end. Oh God, why am I opening Discord? Oopsie. Okay. Hold on. Let me make my camera a bit smaller so you guys can see the title. My bad. Anyway, back to OneNote. Quotient rule. There's a little song. I don't know if you want to memorize it now. I wouldn't. The basic idea is take derivative of top times the bottom minus derivative of bottom times the top all over the bottom squared. So here's an example. Take derivative of top, 7x to the 6th, times whatever the bottom is, sine of x, minus, keep the top the same, x to the 7th, times derivative of bottom, which is cosine of x, and then all over the bottom squared, which is sine of squared of x. Or 1 minus cosine squared of x if you want to review your Pythagorean identity. Studentative limit rule. Never heard of that one. Let me quickly Google it. Studentative limit rule. Huh. What do you mean there are no images, bro? Give me an image of it. Well, how are there no... Okay. I can't find that one online, which is interesting. I'm gonna assume no. Okay. MCQ. Okay. Have you know there isn't any MCQ questions because I'm pretty sure College Board we can find. No, see the thing is MCQ questions. Yes, College Board is gatekeeping them, but you can still find them online if you look far enough and you commit enough time to finding it. I found 2003, 2008 version 1, 2008 version 2, 2011, 2012, 2013, 2014, 15, 16, 17, 18, and 19 MCQs for AP Calc BC online. All online. I could find the PDFs of full MCQs online. Lagrange error bound, I will once we get to series. Oh my god, Vedang, you're not from South Korea. I feel really good for the Calc AP test. Predicting a 4 or 5. Probably a 5, bro. You just need to lock in. Make sure you guys get rest. That's the most important part. And don't stress. Watching for fun, hopefully. I mean, the more the merrier. Wishing you guys luck tomorrow. Get a good night's sleep. We'll probably... song for quotient rule is crazy. Yeah, a song, I mean, it helps some people remember it. I didn't really memorize the song. AP Fortnite exam MCQ. I'm sorry, I don't have access to that. Guys, what is the derivative? Yeah, you're probably cooked. Oh, when I put it into chat, it says it's just... Oh, squeeze theorem. Yes. Squeeze theorem. I could go over that. I don't know why they called it that. That's a weird name for the squeeze theorem. That's what I wanted to go back to Unit 1 to cover quickly because my teacher didn't cover the squeeze theorem. Can you go over... Oh my god, send 2019 BC MCQ. We're solving the Collatz conjecture B. What? What's a Collatz conjecture? I don't think so. Can we please go over polar integration? Lots of love from Iran. I mean, God, I can't go over everything, but shoot, I might be jumping all over the place then. I need a water break. Can you guys give me like a minute? I actually need to refill my water bottle. Hold on, let me hide my face quickly. I'm gonna move. Boop. I'll be right back. I'm good here. Oh, okay, guys, I'm back. Okay, hold on. Let me see if I missed anything. Oh god, so many questions. Oh well. Okay, squeeze theorem, derivative of x. That's just one. You could use the chain rule, but it's just one. For calc, would you recommend studying mainly, or I got one MCQ? That's good. 38 out of 45 is really good. That's in the 5 range. Squeeze theorem, mean value theorem. Never heard of that. Squeeze theorem, yeah, I'll go over it quickly in a second. Is the history of the slave trade going to be unlikely? Squeeze theorem. I'm going over squeeze theorem. Don't worry, guys. Squeeze theorem, like, you don't even need it. It will probably be like one MCQ. On AB, it might be like an FRQ part. It's not gonna be a whole question. Like, come on. I'm in BC. I'm in Calc BC. Yeah, studentative limit rule is basically squeeze theorem, so I'm about to go over it. Acceleration of the boats, BC. Oh my god, can hopeless say no cap skibbity? Okay, no cap skibbity. You happy? Okay. So the MVT and Rolle's theorem. Rolle's theorem is literally MVT for derivatives. It's nothing different. Yeah, I'm in BC. Yeah, no need to spam, but I don't care. Curve sketching. I took AP stats exam. Thought it was wrong for some reason. Okay, stats. Yeah, we have a. I think we have someone working on the FRQ walkthrough. Riemann sums. Know them. Yeah, MVT is. Rolle's theorem is just exclusive MVT. Can like see the y derivative are the opposite of integrals. They just are. So what am I about to get on the AP Calc AB test? 100 minus gets off. Okay. Calc AB, know your integral and derivatives inside out, because that's all they can test you on. I'll review Unit 8. I found Unit 8 particularly challenging. Derivative is the slope. Okay, a derivative is the slope and integral is the area under the curve was unknown. Yeah, I love you, bro. I hope I get a perfect score. I'm going for a perfect score here. BC only topics, that'll be near the end. I must say, okay, I'm wasting a lot of time right now by yapping, so I gotta move on. Start changing units. Okay. Cause you're carrying me, my boy. No cap skibbity. Yeah. Okay. Anyway, yeah, we're all juniors. I'm junior. Okay. Midpoint. Okay. Squeeze term. What is an integral? God. Okay. So many questions. Can I change my source of screen capture? I think I can. So I'm gonna change it to. Hold on. Squeeze theorem. Okay. Yeah, I'm gonna let him do that. Okay, do that. Okay, squeeze theorem. Let me quickly. So squeeze theorem. Okay, there's a good definition. I'm gonna zoom in on that, and I'm gonna change my screen. Let's see. Google. Live streaming. No, that's not what I want. Or is that what I want? There we go. Okay. So here's our good old squeeze theorem. You don't really need to know it, but the idea is. Another name for it is a sandwich theorem, and you're basically, well, you can read the definition there. If h of x is less than or equal to g of x, which is less than or equal to f of x, then x is near a, except possibly at a, and limit as x approaches a of f of x is equal to limit as x approaches a of h of x equals L, then limit as x approaches a of g of x is L. So it kind of says that if two graphs that are always that with one less than and the other one greater than a certain graph, and their limits at some point is equal to a same value, then the graph sandwiched between them has the same limit. You don't really need to know this. This is unlikely to come up. It might be one MCQ, and even then this is like common sense. So now you know. OBS Studio, Microsoft OneNote. Okay. Alrighty. Where were we? Okay, simple. What is this? Quotient rule? Yeah, you know quotient rule. Cosine. Okay, a derivative of cosine. Sine is cosine, but derivative of cosine is negative sine. More trig. Derivative of tangent secant squared. Cotangent negative cosecant squared. These are just some you have to memorize. You could try deriving them on the AP exam, but I wouldn't try. X to the O. X to the X. That's a good one. Okay. I have a whole project made on x to the x for mu alpha theta, unrelated. Do not worry about that one. It's a complex derivative, and you have to know derivative with logarithmic differentiation and chain rule, and it's not worth it. It's not gonna hold. Trust me, it's not showing up on the it's not showing up. I just know that. I mean, I guess I could show you, but like you don't need to know it. Don't know their names. Don't worry about polar curves properties. If there's a no calculator, most of them will be calculator MCQs and FRQs for polar, or they'll give you a graph. If it's a no calculator polar MCQ, then it's most likely you plug in your top and bottom and top bounds for integral, and then you do 1/2 r squared d theta, you know, within your good old integration for polars. The thing is, yeah, you just assume that it's not changing the value of r along the interval from 0 to 2 pi. Can you derive a derivative? No, I'm good, bro. Can you prove how limit sine of x equals 1? Yes, I can. So you get intermediate form if you do direct sub, you get 0 over 0. If you do L'Hopital's rule, you get cosine of x over 1. Plug in your your limit as x approaches 0 of cosine of x over 1 is 1. Another way you could do it is squeeze theorem. I guess Google that for you. So sine of x over x, squeeze theorem. It's a one of the 3 top searches. I don't know what they bounded between, but it gets squeezed between 2 graphs, and then you can approximate the limit there. Squeeze theorem is one approach to finding that limit. L'Hopital is another. I'll stick to L'Hopital. We'll keep moving. We gotta get through it, like 8 more units. Washer method. We'll get there. Derivative of secant is tangent secant of x. Tangent x of secant of x. Derivative of cosecant is negative cotangent of x. Cosecant of x. Here's your 6 trig derivatives. Memorize them while I take a sip of water. They should be already like memorized. Yo, what the heck is going? It gets squeezed between tan of x and cosine of x. Probably. Not sure. Okay, yeah. Okay, well, we're done with unit 2. That's good. I covered squeeze theorem. I covered unit 2. Unit 3. Alright. So, f of g of x. Chain rule. A push or apes FRQ. Oh shoot, apes FRQ. I might have someone working on that. Hold on, I have to text someone. Hold on. I'll text him later. Crap, I can't do everything at once. Do you think taking the AP Calc BC exam while being in AP Calc AB is a fair idea? No, unless you self-studied the BC content, in which case you have a pretty okay chance of getting at least a 4. Chain rule. Take the derivative of outside, keep the inside the same, times derivative of the inside. Think of the lollipop example, which I'm about to open here. I'm gonna show you a lollipop. Where did it go? Yep. Yo, I'm moving way slower than I thought. Lollipop example. The idea is you first, let's say there's a bubble gum inside, but that's, oh yeah, it says bubble gum filled pop. So think of it as lollipop chain rule. You're taking the derivative of the outside while keeping the inside the same, and then only do you get to the inside and take the derivative of that. So you have to sort of move your way in, which is like a lollipop. How do you think the curves of the AP exams will be like this year? I heard all of them are mostly easy, with some conditionally hard, so I'm guessing the curve cutoff is going to be pretty high for all AP exams. How do you integrate 10x to the power of 1/2? Easy. Use chain rule. You bring the 1/2 forward, so now you have 1/2 times tangent of x to the negative 1/2 times whatever your inside is, like the lollipop example, which is tan of x. Derivative of tan of x is secant squared of x, so it would be 1/2 times tangent x to the negative 1/2 times secant squared x. Hopefully the lollipop helped you understand the chain rule principle. It's used by most teachers anyway. No, I'm not American. My accent is not from America. I'm kind of tired right now, so also that could be altering my voice. I can't talk about all these units. Tan squared of pi of x. It's not that hard. Yeah. E of x, e to the u. Now you use chain rule, as I talked before. Oh yeah. If it was, I'll be. I don't even know how to take the factorial of negative 1/2. Let's see. We're all cooking tomorrow. Yeah, we'll all cook, guys. Come on, it's easy. BC only, like, these AP exams after COVID are just like goo goo gaga. Like, we'll all get 5s, trust. Yes, Xiaomik. Shout out to Brown. The GOAT. Okay. Yep. Yeah, we know all this. Okay, table method. Oops, that's not table method. I guess sometimes you have to look at the table and know your stuff. I guess just do. I already got a 5 on AP Chem. Wait. 1/2 secant squared of x times tangent of x to negative. No, you're right. You did nothing wrong. You should be fine. You just rearrange the secant squared of x and the times tangent to the negative 1/2 power. Yeah, that should be fine. Can we? No, bruh. Okay. Anyway, can you shout out my calc teacher? Okay, Miss Studi Mohan. Shout out to you for hoping your students perform amazingly tomorrow and preparing them. Implicit differentiation. This one's an interesting topic. Sometimes I get it wrong. This is very crucial for what? It usually comes up in differential equations, unit 7 as well. What college am I going to? Hopefully this one, but we'll see. Can you please shout out my teacher, Mr. Mutu Raja, the GOAT of Calc 2? You probably are. Implicit differentiation. Okay. So since we're usually differentiating with respect to x, we do nothing. We just differentiate it as we know it. When we do it with respect to y, we just treat y as x and then we just do nothing. If we differentiate y with respect to x, we do 2y times dy dx. You gotta put that dy dx to acknowledge that you differentiated with respect to y, with respect to x, a different variable. So I'm not shouting at them. I'm just tired, man. I'm tired. I'm on unit 3. I have 7 more units to go through. All right, so yes, do it with respect to x. You have to put dy times dy dx after differentiating it. Do it with respect to y. No dy. It will be just dy over dy, which is 1. So don't worry about that. Do it with respect to t. You have 2y times dy dt. So my crotch. I hope I'm saying that right. Shout out to my crotch. Wait, Philip McCrotch. Bro, you're in my school. Oh my god. Okay. Differentiate both sides. Okay, simple differentiation. Actually, no, not so simple. Yeah, you take derivative of both sides. You find what your dy dx is. This one is a little trickier. You differentiate both sides. We take yeah. Okay. Yeah. Okay. Anyway. Oh, I did not even know that's what it meant. Okay. Please shout out Niketh Nalamolu. Shout out to you, calc teacher. Okay. God, so much content. Calc has so much content in it. Implicit, pretty easy. Take derivative, whatever you do with respect to y, multiply it times dy dx as a form of chain rule almost. Yeah. Easy peasy. And then just isolate your dy dx and you'll have your derivative with respect to x and y. Easy. We know all this. It's just yeah, vertical, horizontal tangent lines, numerator and denominator equals 0 respectively of dy dx. Second derivative, not bad. Just do it again. Or is it bad? Hold on. I think it's easy. Implicit is not bad. Restrictions. Arcsine and arccosecant are bounded by negative pi over 2 and pi over 2. As is arctangent and arccotangent, but arccosine and arcsecant are bounded by 0 and pi. So there's that. I'm not gonna show how to derive the derivatives of inverse trig, but here's the formulas that you should probably know. The arcco ones are negative. Arcsine is 1 over square root of 1 minus u squared times u prime. Arctangent is 1 over 1 plus u squared times u prime. And then arcsecant is 1 over absolute value of u times square root of u squared minus 1. Oh no formula sheets. If you still don't know that yet, GG's. Times u prime, and then the co-ones are basically the negatives of those. Easy application. You should know all this. Arcsecant, yeah. Log. Derivative of natural log is just 1 over x. Not bad. Not bad. Not bad. This is just a number. Don't be tricked off. This is just a number, so the derivative is going to be 0. This one's a little trickier. Just know it's 1 over natural log of whatever the base is times u. So it's almost like 1 over u, so almost as the derivative of natural log of u. But now your base is different. It's no longer e. That's why 1 over natural log, naturally 1 over natural log of e times u is just 1 over 1 times u. Now the base is different, so you gotta account for that. Here are all your rules. Try to memorize them. Derive ln x with limit definition. Shoot. I could try. It's not bad. I mean, I don't really feel like doing all that. Good FRQ topic predictions? No, I don't know, bro. You gotta trust me. At the end of the stream, I'm calling every single FRQ, bro. And College Sport's gonna come for me. See, the thing is, not everyone knows this Captain Singers. Like, some people are still may have forgot some derivatives or something. So yeah, 1 over natural log of a times a to the u times u prime. It's pretty easy. Yeah, okay, done with unit 3. We'll call it a day. Wait, no shot of teachers promoting me. Yo, I would not be promoting me. Okay, anyway. Alright, related rates. Some people tend to struggle with this, as do I. There's different approaches. You could do a table setup where you have your rates moment relationship type of deal. For unit 4. Yeah, okay. Known and unknown rates, dv, dt, d theta, dt, dA, okay, whatever it may be. There's something you're usually given in the question. This is a type of MCQ, most likely. You guys want to skip related rates? I thought people like related rates. Yeah, I thought you guys wanted to go over. I mean, I could skip it. Actually, should I just, like, what unit should I go to? I mean, right now we're on unit 4. We have 6 more units to go over. Okay, yo, you guys gotta guide me. What unit do I go to? I did not cover series yet. Mr. Nalamolu, shout out to you. God, I'm so tired. Skip, okay. Oh, oopsie. Whoop. Thank you. I'll always keep one section open then. My bad. Okay. I'm so tired. Okay, I'll always keep one section open. Nobody saw that anyway. Okay, so related rates, I guess. Do I? No, it has important. It has L'Hopital's rule, which we didn't cover yet, did we? So I'll just. Oh my god, so many units request. We should go to unit 6. Do not skip related rates. Unit 6. Name every unit so we can vote which one. Okay. We have unit 4, which is derivative application. Unit 5 is derivative application. Unit 6 is integral. Okay, I'll cover unit 4 quickly. Okay, related rates, not bad. You just are given some information. Here's a practice FRQ. Spherical balloon inflated at the rate of 300 cubic centimeters per second. So 300 cubic centimeters per second is your dV dt. When the radius is 20 centimeters, that's your moment. What is the rate the balloon's radius is changing? You're looking for dr dt. So you know your rate, or for dV dt at least, you're looking for dr dt. You don't know your volume at the moment, but you can figure that out. It gives you, if there's a related rates question, that will give you any type of formula that you need to sort of approach the question. So here they give you the volume, so you can easily plug in your R and see what the moment volume is. Then you could, like, you know what your formula is, so take the derivative of both sides. You have your dr. You don't know what dr dt is, but you know what your R is, and you know what your dV dt is. You plug in all your knowns, and you usually find your unknown. So it's usually not that bad. And then the surface area changing is, they give you that formula as well. So you could just like take derivative of that, and you know what your dr dt is. So it's, most of it is plugging in and reading the question and seeing what is given and what is not. So, oh, okay, likability left. See ya. That's more of geometric related rates, also quite as hard, but one could consider it to be parametric because it deals with time as the third variable. But yeah, this one's a little harder. You have to apply x squared plus y squared equals z squared for it to actually know. But related rates is just like taking what is known and finding the unknowns. Oh, how much? Probably an MCQ or two. Probably like 2 MCQs if I were to guess. Yeah, we're done with that. Hospitals. Yeah, as we talked, sometimes limits are just not conclusive enough, like 0 times infinity. But El Hospital's rule can help us. No, I can't send this one. No, that's my teacher's. Bro, my teacher covered this whole year's derivatives. How? Bro, these... Oh my god, some of these teachers, man. That's problematic. Okay. All El Hospital's rule says is if direct substitution yields 0 over 0 or infinity over infinity, then limit as x approaches c of f of x over g of x is equal to limit as x approaches c of f prime of x over g prime of x. So, not quotient rule. You're not taking the derivative of the quotient. You're taking the derivative of top, moving it forward, and bottom, and moving it forward. And the College Board is also nitpicky on how they want it to be written on the FRQ. Why 0 times intermediate? Why 0 times infinity intermediate? Because it's just like mathematically we can't just say that's 0 and we can't say that's infinity, so we just call it D and E. So no, I wouldn't recommend it. You gotta use your time wisely on the AP test. That's why there's only like 60 minutes on MCQ, no calc. Yeah, please don't. This so right. Okay. El Hospital. Oh, the old way, we could factor it, take out the whole, and then plug in the 6 and we get 5. The new way, we could take derivative and get 2x minus 7 over 1, plug in your 6, 12 minus 7 is 5. So, El Hospital, faster, more effective, less algebra, and overall simpler if you like your derivatives. There's your sine of x over x. You could use El Hospital as I mentioned. Write this one. Okay. Yes. Oh, there we go. Yeah, that's so smart. Yes, Matt Maple is right. So for FRQ on College Board, if there's a limit FRQ part, you can write 0 over 0. That's algebraically incorrect and they're going to take a point off. What they want you to do is they want you to write the limit, draw an arrow, evaluate that limit individually, say what the top equals to, and then evaluate the bottom individually and say what the bottom equals to. Then move on back down if both of those are 0 and evaluate it using L'Hopital. If not, take it again. The thing about L'Hopital is you can take derivatives up to, well, you could keep taking derivatives of top and bottom until you actually get an answer. But like, I believe if you go too far, you're gonna get the wrong answer. So you have to eventually stop. Oh my god, do we need to know chi-squared? Oh, for stats, yes, but Shadow Draconic, no. What do I use in series convergence? All the tests. I mean, eventually I just use all the tests. Can we just say intermediate instead of 0? Wait, can we just say indeterminate instead of... Yeah, you could. Yeah, actually, yeah, that's smart. Should I be mewing during the AP test? Right, no, I'm a junior. Help it out, easy. I just went over it. So that's your fourth approach for indeterminate cases. So yeah. Rewriting, easy. Wait, is it easy? Sometimes you have to rewrite it. There's not going to be too complex of limits on the test, I don't think. Thank you, okay. Yo, what are these comments, man? Okay. PVA, I guess somewhat important. Changing position with respect to time is velocity. Positive, negative, 0 velocity, not moving. Instantaneous velocity is derivative of position at a point. Average velocity is between 2 points is position at that point, position at the other point, divided by the difference in time between the 2 points. Slope of the secant line. Brain rot, yeah, that's so real. Change in velocity with respect to time is acceleration. Second derivative of position. Velocity is increasing when the acceleration is positive. Negative acceleration, velocity is decreasing. 0 acceleration, velocity is constant. Same deal with the instantaneous and average. Speed is absolute value of velocity. Difference between speed and velocity are two different things. Speed is increasing when velocity and acceleration are same sign, decreasing when they're opposite signs. God, yo, I'm actually gonna fail if I keep reading the chat. This brain rot, okay. I'm not gonna go over any of this. Okay, we're done with unit 3, 4, I mean. Unit 5 is pretty, like, implied. Most of it is the same. Critical numbers are where f prime are 0. Hold on, no. Hold on. Yeah, where f prime is 0 or f is undefined. F prime is undefined. So, critical numbers, f prime is 0 or f prime is undefined. Yo, what is going on? Yo, these comments, man. Okay, God. I need to turn on the fan. I'm too tired for this. Okay. Y prime 0, Y prime undefined, critical numbers. Not bad. Increasing, decreasing behavior should be implied from unit 2. Changes sign, point of inflection. If f double prime changes sign, or f prime changes from increasing to decreasing or vice versa, then there's a point of inflection at that point. Point of inflection, yeah, there we go, literally what I just said. So the table is your method to approach these problems that question concavity or increasing, decreasing behavior. Yeah, just use the table method. Understanding, okay. Relative, absolute, extrema. Relative is a maximum, minimum. Absolute is the maximum and minimum. Difference is at. So is, okay, is what it actually is. It's the y value of the minimum or maximum. So maximum, let's say this one's 2, the relative maximum. Or this one is -1, is the relative minimum. At is like at what x coordinate. So for this one, the relative maximum is at 1. Or the relative minimum is at 3. Okay, wait. I already went over related rates. You should not see any hard related rates problem, and even if you do, it's like 1 MCQ. You just need to know the basics, which is just take derivative of both sides, plug in your unknowns, usually involve some sort of implicit differentiation. Tests for relative extrema. One appears more common than the other. First derivative test is sign changes of y prime, which makes sense. If f prime changes from positive to negative at point x equals a, then from positive to negative, then it's a relative maximum, which makes sense. If f prime goes from positive to negative, then f goes from increasing to decreasing, so there's a relative maximum there. Relative minimum goes from f prime goes from negative to positive, so it's decreasing, then it's increasing, so f has a relative minimum. Second derivative test does not come up as much, but it's still really good to know because sometimes you need it. Sign of y prime at horizontal tangent. So you want to find a point where f prime of a is equal to 0, so a critical point, and check the value of f double prime at that point. So take derivative again, and what's the name of the Greek letter which represents the sum of a set of terms? Yo, we're about to get into it. It's sigma, unit 10, trust. So relative maximum makes sense. Horizontal tangent of f and what the concavity at that point is. So if f double prime is less than 0, then it's concave down, so it's a relative maximum. If there's a horizontal tangent, if there's another horizontal tangent, but this time it's concave up, there's a a relative minimum at that point. So easy peasy. Sometimes if the second derivative fails, which is why it sometimes fails, not very reliant, but when both f prime and f double prime at that point are 0, no concavity at that point. Another is when f double prime is undefined, but it's still a horizontal tangent. So, oh, that's an example. Oh no, that's when actually the first derivative is undefined. So just keep that in mind. Rolls through or squeeze. I went over squeeze. Squeeze one graph between two graphs. Find your limit that way. It's not that hard. If you guys want to chat about the squeeze theorem, that's fine. If you want to answer each other's questions, please do, because I'm kind of tired. Increasing and decreasing behavior, kind of easy. Increasing y prime greater than 0, decreasing less than 0. Sign of y prime is your big idea. Find y prime, critical points, which is where y prime is 0 and or y prime is undefined. Sign chart, justify your answer. I'm not doing all that. Concavity, look at double prime value. Sign of it, positive or negative. Sign chart as well. Relative max, I went over that. Relative extrema, I went over that. This absolute extrema. This one's a bit different. Endpoints, okay, this is important. If it's inclusive, there's an absolute maximum or an absolute minimum. If it's exclusive, meaning like the endpoints are not included, this graph has no absolute maximum. The reason being is because it gets so close, but it never actually reaches a value of 3, so it has no absolute maximum. That's a key point to know. Parametric, yes, I'm going over everything today. I'm just trying to get through it and maintain my consciousness and sanity because I'm so tired. Look at these graphs for now. They're really good for importance of endpoints and absolute maximum and minimums. Yeah, the curve is really good for BC. It's like around, all you need is a C bare minimum for at least a C, so like 70 out of 108 points to get a 5. So even if you miss like 5 MCQs and miss an entire FRQ, you're still like guaranteed a 5. Yeah, BC's got like top 3 highest 5 rates out of OAP exams because everyone is usually always prepared for it. Okay, so that should be implied. We start looking for relative extrema at points where, thank you for $1. That's very nice. I really love that. Celebrate their first super. That's actually very generous. Thank you. Start looking. Shout out to Shadow Draconic. I guess I have to say that. All right. relative absolute extrema. So find your critical points, and yes, find your critical points. That's for relative extrema. Yeah, thank you so much. Thank you. Truly. Okay. Sine of f double prime at f prime 0. That's another key point. Hold on. Or undefined. Then we were f prime. Okay. F prime sine of f double prime. Okay. Oh, there we go. Oops, missed the slide. Okay. Absolute extrema works. You use your relative extrema and endpoints. You gotta consider your endpoints, unless it's exclusive, I believe. Then you create a candidates test. What candidates test is let's consider this function. We're given an interval, inclusive and exclusive. So 4 is not included, but -1 is. So, okay, take derivative, find your horizontal tangent lines, which is when f prime is equal to 0, find your x's. -2 is not in domain, so we don't consider it, even though it fits the critical point. Then you can check your sine of f prime, or sine chart, and then see whether it's positive or negative or vice versa. Once you do that, you can see that there's a relative extrema at x equals 0. Yeah, which is relative minimum. Oh, maximum, because it's increasing and then decreasing. So it's a relative maximum, and then relative minimum at 2 because it's decreasing then increasing. And then you could do your candidates test, which is you plug in all your critical points as well as endpoints. And while you may see that at 4 it's 131, the absolute minimum is at x equals 2 because that's the lowest term. Absolute minimum is -13 because that's the value. There's no absolute maximum. There just isn't an absolute maximum because 4 is not in the interval. And the idea here is that if it's closed, but it's still maximum, there's just no maximum there, which may sound odd, but it's not a maximum. There's no maximum here. You may think, oh, maybe it's close to it. It just doesn't exist. God, why are you all talking about LeBron? Okay. Candidates test. Know it. Can't keep. Okay. Implicit optimization. Wait, we went over optimization? I do not remember going over optimization, chat. Huh. Do we? We didn't do this. Wait, was this always available? Yo, we might be winging it. I know optimization, it's implied. Trust. Can you? Oh, I'm not. Okay. We do need optimization. It's just unlikely to come up. Like, it's still part of the curriculum. So, oh, just know it. You gotta know it. All right, I guess we're going over optimization. So it's a bunch of equations you're working with. You're trying to find critical points. You're usually trying to maximize or minimize something in optimization problems. We can do this one. And only this one, because I don't feel like doing more. Find okay, maybe this one's hard. Find two positive numbers whose sum is 17, so that the product of the larger and 6 more than the smaller is maximized. Can I draw? I don't think I can draw, because it's a content library. But, okay, how you would approach this is, maybe I should type it in the chat. Find two positive numbers whose sum is 17, so that the product of the larger and 6 more than the smaller is maximized. So that the product of the larger, okay, I think I know what this means. Okay, two positive numbers. Okay, so x plus y equals 17. Oh, I don't know why I typed that. I thought you could press enter. I guess not. So the product of the larger and the 6 more than the smaller is maximized. So that the product of the larger, okay, we'll make y the smaller. And 6 more than the smaller. We're trying to maximize a, take derivative, And find two positive numbers whose sum is okay. Okay. I don't feel like doing this one. This one's too long. Okay. So optimization, you just have to, it's a logical problem. It not only requires you to know calc, it also requires you to actually piece this together. Because this could be a possible question, and you just simply have to like understand what it's saying, set up system of equations, take derivatives, find maximum, minimums, whatever it's asking for, through the methods we already covered. So yes. Do it. Wait, do it. So many questions. I don't feel like doing it. I know I could probably do it. I can't write here, and I don't want to. I guess I could write it on my phone actually, but how do I show you all the picture? Oh, I could just show you the picture. I forgot I'm streaming to my. Okay, let me actually try doing this then. I could just write it on my phone. So x plus y equals 17. X times y plus 6 equals area. We're trying to not area, I guess. We'll call it P. We'll call it product. So that the product of larger and 6 more than smaller is maximized. Okay, so xy plus 6x equals P. You could rewrite what y equals to. It's 17 minus x. 17 minus x. 17 minus x plus 6x equals P. Negative x squared plus 23x equals P. We're trying to maximize that, so we're trying to find two positive numbers. Okay, so we're just trying to maximize it. Take derivative, so negative 2x 23 equals dp dx. We're trying to maximize that. So when does it equal 0? So minus 20. Okay, so x equals negative 20. Okay, 23 over 2. Sign short 23 over 2. The minimum value can only be 0. This can be, okay, it can be 0, but it can be 17. Okay, so negative 2x plus 23. Okay, so, oh wait, 23, wait, okay. That's negative, that's positive, that's negative. Okay, increasing, and then it's decreasing. So we want to use that as the x value, two positive numbers. Okay, so our x is 23 over 2. Our y is 17. Okay, so 34. Okay. Um, 23 over 2, 11 over 2. Okay, this one's like, it's a long problem, but I feel like I'm doing something. Is maximized. We're trying to maximize it, so. So I feel like the two positive numbers that I got are 23 over 2 and 11 over 2. So, yes. My work is setting up the two information they gave me, x plus y equals 17, and then x times y plus 6 equals P, which is product maximized. I'm just using P for example. I take derivative, right? Yeah. I actually changed the y equals 17 minus x based on our first equation. I distribute the x, we get negative x squared plus 17x plus 6x, that's negative x squared plus 23x. Take derivative, you get negative 2x plus 23. Find your critical point, which is x equals 23 over 2. Set up sign chart. You could see that the product is increasing before that and decreasing after, so we have to use this for our x to maximize the product. And then we could solve for y by plugging that x back into x plus y equals 17. So sorry that took a long time, but I'm pretty sure that's how you would approach it. They require logic. They're just like, they're very weird questions. This is just 11. Yes, that is just 11.5. I'm gonna move on now. Optimization, guys, don't stress over it, honestly. It's unlikely to pop up. Yes. -6. Yeah, I think, yeah. I just use calculus to approach it. I mean, I don't know if you use calculus. Yeah. It's always greater than, you guys have interesting ways to approach it, but anyway, antiderivatives. Okay, so antiderivative, literally opposite of derivative. So just like if f of x is the antiderivative of f of x, then take derivative, you get 2f of x. Pretty easy. Yes, and yes, we're on unit 6. Unit 5 was short. 6/10, 3/5. How do you differentiate a constant? It's 0. Derivative of a constant is 0. Okay. Anyway, let's get through this. Stream will probably end at 4, by the way, Eastern time, so in 30 minutes. If I get through everything. Do unit 6, I'll make equal 47. Okay. Unit 6. So when you take the integral, remember your plus c. It's just, what do you take the derivative of to get to your answer is basically what an integral is. Was the answer 11 divided by 2 or 20? Wait, were there 2 values? I only got 1 value. 23/2. Yeah, I got 23/2 for A. For wasting time, well, welcome. Okay. Yes, antiderivatives. Solve the differential equation. Well, we'll have unit 7 to do that. Integral notation. We got the integrand, what is inside. We got the integral symbol, the long s, and we got the dx. Power rule. For derivatives, bring it down, subtract by 1. For integrals, add 1 to the exponent, multiply by 1 over exponent plus 1. Except for 1 over x, which we'll cover in a second. They're the same thing. Antiderivative and integral are the same thing. Okay. Constant, luckily, same as derivatives. Just bring it to the front. We'll deal with it later. Power rule, 1 over n plus 1, where n is your exponent, times un plus 1 plus c. Remember your plus c. Rewrite before integrating. Yes. Rewrite before integrating. We don't like this. We like this. Okay. So this can just be turned into 8x cubed, from which you could just add 1 over 3 plus 1, which is 1 over 4, times, you can bring the 8 to the front, we'll deal with it later, and then x to the 3 plus 1, and you get 2x to the 4th plus c. Same thing down here, just negatives. Implicit differentiation and differential equations. So implicit is differential equations you have to do integrals to solve. Implicit differentiation, use derivatives to solve. So actually, yeah, there we go. I think I just answered your question. Okay, 6 trig integrals, which are kind of implied. Okay, I would not do that. Now you're just being annoying to the grader. Yeah, I would not write that as the integral notation. Maybe. I would not try that. That's like using tau instead of pi on the test, which is just annoying. Integral of cosine is sine because you take derivative of sine to get to cosine, plus c. Make sure you have your plus c. Integral of negative sine of u du is equal to cosine because you take derivative of cosine and you get negative sine. Yeah, no problem. Tectonic. Plus c. So integral of secant squared u is equal to tangent because you take the derivative of tangent and you get secant squared. Cotangent, take derivative of it, you get negative cosecant of squared. So in 7 hours. For you, good luck. For us, it's in 15 hours? 16 hours? 16 hours. We need log though. Wait, is it in, am I tripping? No, 12 hours? Yeah, 6, yeah. Yeah, 16. Yeah, 16 hours. Okay, pretty easy. These are not new. It's just integral of sine is negative cosine because negative cosine derivative is sine. And then, yeah, it's just, once you can go one way, the other way is pretty easy. Except some special cases, which I'm about to cover. General solution to a differential equation. So here, they're doing differential equations already, the basics of it. They're rearranging the dx's. Self-study, BC, AB, Khan Academy, good source. Practice tests out there. Yeah, that's all I have. Oh yeah, that one's hard. Yeah, I'll go over bounds. You can do it, trust. Lock in. Okay, general solution. It's plus c. The general solution is your plus c because you're not really given any information to find the particular solution. Particular solution, on the other hand, you're given some point to work with, in which case you would solve the differential equation and plug in your point to solve for c. We're plugging in 1 for x, so now 2 equals 2 plus 3 plus c. And we don't know what c is, but we can find c because this is literally simple math. So we just found our particular solution. We just substitute back into our y and we have our constant. Any tips? Do practice tests. At this point, I'll just rest. I want to rest, but I gotta get through this. Differential equation with double, what is it? With f double prime. F, okay. So, take integral of it, you get 4 sine of x plus c. We're given what f prime of 0 is 2, so plug in 0, you get 0 plus c equals 2. We know c is 2. Oopsie. Now we have that our f prime of x is equal to 4 sine x plus 2. Take integral of that again. You have a different constant, which you can label d or c sub 1 or whatever you want to label it as, just as long as you keep track of it. The Movir's theorem. Hold on, I gotta Google that. The Movir's what is this? Powers of complex numbers? Yo, this gotta be a joke, right? Oh, I am not doing that. Why is there an I there? Yo, that's gotta be imaginary. Yo, I am not doing all that. Yeah, I'm not doing the Movir's theorem. Okay. Differentiated matrix. Save that for Calc 3. Yeah, it's not tested. No, you guys are going above and beyond. You guys lock in for the basics. Worry about the complex in your free time. Same thing but PVA. Not bad. Try these. I don't want to. No. There we go. If you want the answers. Integration is not that bad. Okay. Wait, hold on. E to the u. So e to the x, derivative of e to the x is e to the x, and integral of e to the x is e to the x, plus c. So now do not pull out my stream during the test, bro. Derivative of a to the x is natural log of a times a to the x. So natural log of a is a constant, so you can just bring that to the front. So now you have that the integral of a to the x dx is 1 over natural log of a times a to the x plus c. Old stuff gives new stuff. Remember the negative power and how it can't be that. Wait, so in terms of basics, how do you divide a rational theorem to find a limit with long division? I am not sure. Integral of a polynomial. You can, if it's plus or minus, you can separate them into separate integrals and then just add them up later. So it's not that hard. Polynomials, just treat them as individual terms and take integrals of individual terms. if I started watching your stream. Yeah, it would be considered cheating. I don't know if that would actually involve me as well. I was gonna get my score canceled. Back when I mentioned the power rule with 1 over n plus 1 to the x n plus 1, if it's negative, you get 1 over negative 1 plus 1, so it's 1 over 0 times x to the 0, and you get undefined. This is when the integral of 1 over x, you don't use the power, you use the natural log. So 1 over x, the integral of that, is just natural log of absolute value of x plus c, or u. Why is it u? I'm about to cover in a second. For that natural log, why do we use absolute value? Because as you can see, the derivative of natural log of x and derivative of natural log of negative x, it both evaluate to 1 over x, so it doesn't matter what the sign of x is inside the derivative or the integral. Actually, we don't know what it is. That's why we know it's positive, but we don't know if we started with negative, so we just put absolute value and call it a day. Okay, x squared plus 3x plus 2, 5x plus 7. How do you simplify? Long division. I'll rely on long division. Otherwise, if it doesn't work, then it's unlikely to be a problem on the test. Yeah, I'm taking it tomorrow. Wish me luck. I feel like I'm forgetting information because I'm just tiring my brain at this point. Okay. 2ln or not ln? What is this? U sub? We don't know like half of this. I didn't cover it yet. Monomials. Oh, this is another effective one. This one you just separate each term and put it over the denominator. So like 2x cubed over 2x minus 3x squared over 2x plus 8x over 2x minus 12 over 2x. Simplify them as needed. Treat them individually. What the derivative of those? For example, okay, so derivative of absolute value does not exist in algebraic format because, well, it just doesn't. You have to physically graph it and then make your own sort of. Jeremy Krug, no, I do not. Will my Pookie Bear, Liviton James be on the test? Let's hope so. If there's like a basketball question or something. Cosine, yeah, that's pretty easy. It's just know your algebra. They didn't put the rules here. That's fine. Okay, we learned this. Quick review. Okay, quick review. Now inverse trig. The integral of 1 plus u squared is tangent of u plus c. These are just reverse, except for this one, there's no absolute value around u. Take in mind. But there is in the answer. Arcsecant of absolute value of u, so... Yo, that's just cruel. Oh wait, you can't do that if I private the stream now, can you? And then just unprivate it when the exam's over. I might actually do that now. Okay. Oh wait, but people have exams on different times, so dang. I'm going for perfect score. Hopefully I get it, but can you also go over the questions where they give you the terms of the Riemanns and you have to find the integral expression for it? Integral expression for it, terms of the Riemann sum. Hold on. Terms of the Riemann sum. Integral expression for it. Huh. I don't know those type of questions. I feel like I know what you're talking about. I will get to it in a second. But first, basics of Riemann sums. Very easy. RRAM. Use the right point and make your rectangle. I'll cover if it's over or under approximation. Oh, did I? Oh, is that what it was referred to? That one? Yeah, don't worry about it. It's like very few questions. If you actually want me to go over it, I don't think I will, but okay. LRAM. Use the left point, make your rectangle with that height. And then split it into how many rectangles you need. Wait a second. Oh, so my teacher did write this. Interesting. He just made it into an integral pretty quickly. Okay, anyway. Forgot. Okay. Right. So same thing except you're using the right height. So it's going to be like you're using the right point of the graph as your height for the rectangles. MRAM. You're using the mid. So you're taking like 2 points and you're taking the middle. Let's say x equals 0 and x equals 2. you're using the height at x equals 1 and you're making your rectangle based off that. So yeah, that one. So tectonic, yeah, the integral thing, like, are you taking BC or AB? AB or BC? Because on AB, it might be a question. On BC, not so much. It might be like one MCQ, and yeah. Wait, what is it? Oh, chain rule. Okay, yeah. Just review of chain rule. Trapezoidal is a bit different because you're taking 2 points. You're finding their average. So this point plus whatever y value is here divided by 2 times your width, however many rectangles you have. Trapezoidal. God, I'm losing it. Okay, overestimate or underestimate. Okay. So, LRAM. If it's increasing, it's going to be underestimate. Hold on. So, LRAM, if it's increasing, the left rectangle approximation is an underestimate. If the function is decreasing, then it's going to be an overestimate. Vice versa for RRAM. It kind of makes sense. Draw a quick graph, draw your rectangles with whatever bounds, and then you could see if it's an overestimate or underestimate. So, BC. Okay, so yeah, don't worry about it, tectonic. So BC, you should be fine. It's like one question, and even then, just skip it and move on. So, okay. LRAM, RRAM focus on increasing, decreasing behavior in terms of overestimate and underestimate. MRAM, TSAM, trapezoidal and middle, depend on concavity of the graph. So if it's concave down and you're using the midpoint Riemann sum, like the midpoint rectangle Riemann sum, you can see it's overestimate. You could sketch a quick graph. So it's an overestimate for concave down. For concave up, you're using the bottom, so the rectangle does not capture like this area right here. So concave up, underestimate. The questions I'm talking about is the 1988 BC. Oh, that's actually good. I'm gonna review that. Wait, 1988 BC question 24. Hold on. I'm gonna quickly do this. Let me quickly review it. I don't know if actually I can pull it up. Probably not. Gosh. I'll pull it up on my second computer. That's why I actually have it. Okay, well for now, look at the table. TSAM is vice versa of MRAM. Both depend on concavity. Come on, open. Okay, there we go. Oh, 1988, 24. Okay, yeah, I see it. Yeah, that one's tough. Yeah. Okay, I don't need to open my computer then. I don't worry about it. Honestly, it tests your knowledge, but like, you'll be fine. Yeah, don't worry about it. Honestly, it's like one question, and it's a hard concept to grasp this late in the day before the AP exam, so don't bother. Okay. Here's how you would set up a table. You don't really need to. It's kind of easy to do these approximation. Except for trapezoid. Add up the two heights, average them, multiply by your width, add all the trapezoids. Definite integrals. So regular indefinite integrals give you just the antiderivative, fx plus c format. Definite integrals, their answer is a number, and they give you a net area of a function between a to b with respect to x-axis. Using geometry, this stuff, but am I cooked for geo? Probably not. We're in Georgia, state of Georgia. No, taking BC without taking AB is not difficult unless you struggle with math, in which case, good luck. Geometrically, literally just find the area under. Simple. It's just circles, semicircles, and triangles and squares. You know, not that bad. Above, below, do you know that if you're going from left to right, from left to right, this area is positive. But if you're going from left to right and it's under the x-axis, this area is considered negative. You can have negative area, but the definite integral is negative. But let's say we start at 8. You're going forward. This is negative area. You're going from 8 to the left side now, even though it's positive. But because you're moving from right to left instead of left to right, this area is considered negative. So both of these areas are negative for the integral. Here's what I sort of mean. Apologies. If we're bounded between 0 and 8, you're going from bottom to top. So from 0 to 8, this is positive. 8 to 16, negative. 0 to 16, 0, because they cancel out. And then from 8 to 0, starting here and going here, it's negative. So just keep that in mind. Area under velocity curve is displacement. Not this. Yeah. So displacement from A to B. God, so many comments. Enthalpy, bro. I am not going over physics right now. I'm cooked for physics either way. Integral notation. First fundamental theorem of calculus. From definite integral from a to b of f of x dx is antiderivative at b minus antiderivative at a, as long as f of x is continuous on that closed interval, by the way. Equivalently, a to b of g prime of x dx is, well, that antiderivative. Riemann sum, basic definite integrals, arithmetic, easy, done. Oh my god, that's only 6a. Yo, we're cooked. 6b. U sub. Alright, I guess that's a big idea. How circuits... Bro, I do not know how circuits work. Actually, I should be knowing. Yesterday was good. Are these your notes? Yes, they're my notes. Well, actually, they're my teacher's notes, but mine are basically identical with worse handwriting. Compute and integral functions for limits. Series is memorization and application and basically grabbing your right tests and time to piece it together. Curves, polar is a little hard, I guess, especially when it's like sine of 3 theta or 4 theta when the period changes, so I guess I struggle with that. I need to move faster. This stream might go a little bit longer, which is problematic. Let's say 4:30 actually. Okay. God, I'm so tired. Should I plug in my computer? I'm gonna plug in my computer. When is AP Pre-Calc? 12 p.m. Eastern on Monday, May 13th, 2024. If you mean the review session, that's not happening. Unless I have some volunteers from my Discord who are taking AP Pre-Calc who want to host a study session in the channel, like the voice channel. Feel free to do that. But we're gonna keep moving here. How do you conjugate? I don't even predator tense for Spanish. I haven't taken that since like 10th grade. How do you not know about calculus? This is a review session, not a teaching session. That's why I'm kind of like yapping. So the way the way u sub works is you want to use a u that cancels out later. So dx turns into du over u prime. So let's say this is our u. Let's take derivative of it. So now it's 2x is our u. So it becomes u to the 7th. Thus, this 2x cancels out because dx becomes du over u prime. U prime is 2x. It cancels out. Our integral is 1 over 8 u to the 8 plus c. We know what our u is. We substituted our u to begin with. It's x squared plus 5. Plug it back in. Oh my goodness. Yo. What the... AP CSP live session, hopefully Tuesday, if I survive. Why is bro dictating the... La fecha? ¿Cuál es la fecha? Es 10... I forgot. Es dos de la... Okay, I'm not even trying. Do you need to accent marks on the AP exam? Can you send these notes? I can't, I mean, I don't have access to these nodes. There's too many of them. So yeah, I don't know. Actually, there's some unlisted links, but I don't know if I can paste every single one of them. Okay, choose u so that u prime is elsewhere in the, yeah, multiple of u prime. Make sure u prime eventually gets canceled out. Simpler is often better, because then you don't have to worry about it later. Practice is important. U prime takes practice. X squared, that's our u. U prime becomes 2x. 2x cancels out with 10x. Becomes 5e to the u, which is 5e to the x squared. So it's that easy. Plus c. Base A a little harder. You know normal lines? I don't think so, but do know them just in case. Unlikely to come up. Oh my god, Siri's listening. Oopsie. Differential equation. Yes. God, okay. Okay, just take integral, find your y, find your c based on your point. Not that bad. Natural logs. Oh, these are important. Integral of tangent of x is negative natural log of cosine of x plus c, or natural log of absolute value of secant of x if you just bring that negative to the exponent. This is just something you have to memorize. And the integral of cotangent of x is natural log of absolute value of sine of x plus c. Oh yeah, integral of secant of x is natural log of absolute value of secant of x plus tangent of x. 8th grade. Okay, that's crazy. What questions? These questions? They're just part of my notes that my school offered that I sort of followed throughout the whole school year. Cosecant x integral is negative natural log of the absolute value of cosecant of x plus cotangent of x. So, okay. Not sure why nothing's written here. Okay. Great. What is a radian? 1 radius. Can you make AP Bio and CSP reviews? Bio, no. CSP, probably. Oh god. Okay, we should find these questions. Okay, Mr. Nalamolu and Mr. Prabul. Yeah, Mr. Nalamolu and Mr. Prabul. Yeah, please shout out. I mean, I'm sorry, I'm so tired. Yes. Hopefully you guys are learning something. My teacher never talked about them, so I assume they weren't important. I know there's normal force. So normal line is basically perpendicular to the tangent. Don't worry about it, honestly. That's all you need to know. If you want to find the point slope formula, you take the negative reciprocal of the tangent line. No, of the f prime at that point. That means what is SOHCAHTOA? SOHCAHTOA is how you do your sine, cosine, and trig in general. What's the large S sign? Bro, that's the integral. Okay. I didn't take AP Bio, so I can't give any advice, but I heard it's kind of tough. It's very conceptual. I don't like conceptual classes. du dx. For definite integrals, make sure to change your bound if you're doing with respect to u. Base AE. Okay, easy. Arctan. There's a formula. I don't know. Did I cover the formula? Maybe I didn't. It's fine. Okay. Your A is 4. The formula is usually 1 over a squared plus u squared. And then, okay, I don't know where all of them got, okay. Long division, heaviside method for integration by parts. No, what am I saying? Oh, there we go. I skipped a lot. Apologies. Yo, there's so much content. I don't know if I have enough time to go over all of it. Okay. So, the formula is usually 1 over a for integrals of these that mimic the arctrig. 1 over a times arctangent of u over a plus c. Our u is x. Our a is 4 because it's a squared. So it's 1 over 4 arctangent of x over 4 plus c. Okay, what anyway, integrating with algebra along divisions one way, pretty easy. Completing the squares another will usually give you arctangent. Or here it gives you something, arcsine, I guess. Product rule, okay. Integration by parts. Okay. Integration by parts, okay. I don't want to show you the proof, but the general formula is u dv is equal to uv minus the integral of u dv is equal to uv minus the integral of v du. Okay, so choose your u and dv, find du derivative and v integral of dv, then set up your uv minus integral of u or of v du, evaluate, and yeah, this is a good method. U dv du v, and then you move from left to bottom, right to left to set up your integral solution. I'm 17. I'm getting too old for this. U du should be simple. The derivative should be simple. dv v should be easy to integrate. Liate, you can memorize this, you don't have to. It's how you choose your u. Best u, worst u. Okay, I gotta turn on the fan. Actually, hold on. Let me do this. Turn on the fan. It's so hot in here. Okay. Spinning. Okay, it's spinning. So, Liate. You can memorize it, you don't have to. At this point, if you practice integration by parts a lot, you know how to choose your u and your dv. So, okay. Choosing u, easy. Okay. Table method, that's another approach. If you have one of the terms that is multiplied as x to a certain power, no, it's not allowed writing notes on your hand. Probably not, I don't think. So you would set your u as x squared and dv as something that can be integrated, and then you just keep taking derivatives until you get to 0, and then you would do draw arrows, which is these terms being multiplied. You do keep, change, keep pattern until you get to 0, and then that would be your integral. This is a secret method. You could probably learn more about this online. You should probably know this. Single term integrands, arctan. You don't need to memorize these because you can use integration by parts to easily solve them. Yo, stop talking. Okay. Fine. Okay. This one's weird. I'm not even gonna talk about this scenario because it's too lengthy. But sometimes you keep like doing integration by parts, and then you get your integral on one side again, and so you're like, why do I have two of these integrals? Or like, why does this process never end? And the idea is that you can just bring the same terms on one side. Right here we can see that it's on both sides, so we can just bring it over. They're literally the same term, and then you can just solve your integral like that. It's possible, but you have to get everything else like perfect. Graphing calculator, yo, 5 is actually, without graphing, is crazy. You have to get everything else right, I think. Partial fractions, simple algebra. You usually get like 2 natural logs. Guys, I feel like if I keep doing this, my brain's gonna get roasted for tomorrow, so I gotta move through this faster. Converges, diverges, improper integrals. Simple idea is, don't do, maybe you're used to the bar method and putting your bounds right here after solving for your integral. Don't do that with infinities. This is incorrect, especially in FRQ. Please don't do this. This applies to FRQ 6 when they might make you use the integral test. Don't do this. Set up limits, evaluate, say converges or diverges. Don't do the bar method. do the limits. That's the main idea. Sometimes it's a vertical asymptote, in which case it is improper integral problem. Yes. Sometimes the vertical asymptote is within the bound, which is when you have to split the integrals. I'm not reading the chat. Green's theorem? I'm just learning this information today, bro. Unlikely. What the? Yo, vector calculus. Okay, anyway. 6C. This one should be quick. Green's theorem is not on the test. Nah, this class is easy. It's just a lot of content. That's the problem. I like my balls. I mean, I don't know why I said your name, but that's fine. It's just, it's not a hard class. It's just a lot of info, but it tends to repeat. So, God, I'm so tired. Okay. Definite integral as a function. Just integrate it, plug in your bounds. Top minus bottom. Second FTC. Not bad. Take derivative. If it's a constant, it's just a constant. So it just becomes f of x. The dude's name was like my balls, bro. What was I supposed to say? Okay. 10 of x. Okay. Formula of g of x. Okay. Yeah. So when you're taking derivative of that, okay. One way is to simply take derivative of 3t squared, which is just t cubed. You know, 1 over 2 plus 1, which is 1 over 3 times t to the 2 plus 1, which is, yeah, so it gets t cubed. Yeah, and that 3 cancels out with the 3, so. Okay. Anyway. And you plug in your top and bottom bounds. That's how you get your g of x. If you want to find g prime of x, keep 3t squared the same, plug in top, times derivative. You have to do your chain rule here, sort of, minus plug in your 5x times derivative. Here it is in written form. I'll drink some water for now. Stay. Okay. ¿Cuál es tu nombre? No voy a decir mi nombre or something. Easy. Graphically understand your accumulation functions. Second FTC FRQs, easy peasy. First FTC applications, easy peasy. Just use your first fundamental theorem of calculus. Units, not bad. Will you have to? Oh, no, I'm not reading that. I'm actually done with these comments. Calc, okay. Can't do it the old way, because sometimes is Princeton Review good? I tried it. The problems are too hard for me. I prefer the other MCQ sets provided by College Board themselves. But it is good practice. It over prepares you, which means it prepares you just enough for the exam. Yeah, I'm reading the chat. I mean, I have someone else reading the chat, but I'm just like so tired. I can't read it. Okay. Yeah, Mickey, I can't read everyone's chat. It's just, oh, this mouse is for the other computer. What am I even doing? First FTC. Net change of an amount from TA to TB. Initial value plus net change equals end value. Yeah, these notes can be shared, Chad. If you want to, we'll leave the stream published and you can go back and review over any section you want. Pause at the times you need. It's pretty good though. It's oh wait, you're replying to someone else. Yeah, not as good as College Board. That's what I'm saying. Princeton Review is not the best. I pay $4. You pay $4? No, I can't share the. Wait for what? Oh, test for you. $4. Nah, that's not worth, bro. Easy. This is just application. How you would naturally set them up. Okay, let me scroll down here. Okay, if you want to look at these problems. PVA. We come back to PVA. Average speed is absolute value of v of t, integral of absolute value of v of t. Average velocity is no absolute value. It's just velocity. Yo, what? God, I'm getting to series. Very close. We'll probably be there at like 4:20. Hopefully. Maybe earlier. PVA finding, easy. Just look at the graphs and yeah. Rate of change. Okay, this is actually important. We're getting to the theorems, which are the average value of f of x on closed interval is integral from a to b of f of x dx divided by. I did go over partial fractions. I went over them pretty quickly. Leave it public. I will try to leave it public. Probably like Georgia Tech. Polish accent. Yes, Joshua, 420 for series. Partial. To use more. No, I don't have Polish accent. Maybe I do. I don't know. I'm too tired. Integral of f of x over b minus a from a to b. Integral from a to b of f of x dx over divided by b minus a is your average value of f of x. Average rate of change is also important. Average rate of change is just fb minus fa divided by b minus a. Slope of the secant. Theorems. This is very important. This may come up several times. Yodi gang, no. How many hours? Ours is in 15 hours? No, wait, what am I saying? Oh yeah, 15 hours, yeah. 16 hours actually. Intermediate value theorem states for a continuous function all y values between two y values must exist. Intermediate value theorem, IVT. Know it. Continuous. Has to be continuous. Extreme value theorem could come up. EVT. If f is continuous, f has an absolute minimum and an absolute maximum on the closed interval a to b. Rolle's theorem had some people talk about this one. If f is continuous and differentiable and f of a equals f of b, there is some c within ab where f prime of c is equal to 0. This makes sense. In order for those two y values to be the same, and the function is continuous and differentiable, it has to either decrease and then begin increasing, or increase and then begin decreasing, or just stay as a straight line. Either way, there is some c for which f prime of c is 0, even if there are several of them actually. Curve is very generous for BC. MIT with this one, unsure. They probably have a lot of students who found calculus easy. Are you good, bro? No, I'm not good, bro. I'm so tired. Mean value theorem. Continuous and differentiable. Then there is some c in AB such that the average rate of change is equal to instantaneous rate of change. So slope of tangent is equal to slope of the secant at some point throughout the graph between a and b. MVT for integrals. If it's just continuous, it doesn't have to be differentiable. Y value of f is equal to average value of f at some point between a and b. Can we go over how to prove theorems? You don't need to prove theorems for the exam. You just need to know what they are and understand them, what they mean, basically. Unlikely. Unlikely with 1.2 GPA. Very unlikely. Okay, I think that's it, right? More practice. Yep. Finally, we're done with Unit 6. Oh, that's my name. Let me open this one. Unit 7. Differential equations. Whew. Probably Yo, some of y'all are just trolling at this point, okay? Or like how to put your answer into context. So putting your answer in terms of the theorem is, if you know the theorem, do the steps that show, like, let's say MVT for derivatives. Just show that the instantaneous rate of change does equal the average rate of change over whatever interval the problem gives you for f or q, let's say. And then just say, yes, because instantaneous rate of change is equal to average rate of change on this interval by MVT for derivatives. So yeah, that's 232 votes is insane. Okay, well, 78% you say yes, so let's get started. Differential equations. An equation equals with a derivative. dy dx equals 2x, slope field. Just draw a bunch of lines. Draw a bunch of lines. A particular solution. Put a point. Start going along the lines. Try your best. I don't think they're too harsh on how you draw it. Stokes theorem, unlikely. I don't know if slinging dope is a good... am I cooked? What's the limit? Yeah, you're cooked, buddy. Slope fields, yeah. Okay, slope fields, yeah. Let me start moving faster. Slope fields, easy peasy. Slope field, particular solution. Describe all points at which solution curves would be increasing. That's when dy dx is positive. So x minus y is positive. X is greater than y. All points below the line. Y equals x. Which makes sense. Concave up. Take another derivative. You would have to do implicit. And all points above the line, above the y equals x minus 1 line. Okay, plus c, like, the thing about plus c is the only time you can forget it is differential equations. MCQ, it doesn't matter because the answer choices sort of remind you of the plus c. Tangent line approximation. Oh, also forgot to mention, integration by parts and partial fractions integration. They're all BC topics, I believe. So if you're an AB, don't worry about what I just yapped on Unit 6 or part of what I yapped about. But BC, do go review those topics. Equation of the line tangent to y equals natural log of x at x equals 1. Take derivative. You get y equals 1 over x. Plug in 1. You get slope of 1. Add 1. Natural log of 1 is 0. Y minus 0 equals 1 times x minus 1. So yeah, there we go. There is no pre-calc hope session. Preview session. Is invertible. I'm not sure what that means. Gaussian integral. Laplace transfer. That's beyond calc. Pre-calc isn't real. Real. Okay, tangent line approximation. You're using a tangent line. It makes sense. Overestimate, underestimate. If the graph is concave down, you're doing a tangent line approximation. It's gonna be an overestimate. You can see why. If concave up, and you're doing a tangent line approximation, it's gonna be an underestimate. You can just visualize it. Euler's method. I'm gonna go straight to the table. The idea is they usually give you dy dx. They usually tell you how many steps. I would set up a table. You have your x, you have your y, you have your dy dx, you have your dy dx times delta x equals delta y, and then you would use that delta y to add to delta y. You'd use that new y for new dy dx. You get your new delta y, and then you keep going until you reach whatever approximation you're trying to reach. Okay, no more examples of that stuff you should already know. Separable equations. Just put your x's and your y's on the same side. It's that simple. And then just integrate it. Put your dx's with your x's. Put your dy's with your y's. I don't know what the compromise of 1850 is. Was. Find the general solution. Value of y. Yo, I'm so cooked. Yeah. Carrying capacity. Yeah, okay. Anyway. We'll keep going. General solution. Pretty simple. Use your C. Oh, you can't use the C. Keep. Okay. Don't do any bad algebra. Don't take out your constant, even if it's under the root, and just call it a day. That's not how it works. So for C, differential equations, they're so fun. Easy peasy. Proportionality, this is like an ELA type of question you can get. BC exam? No, because it's tomorrow. I'm taking it tomorrow. The BC exam, both of us. Okay. Just understand the ELA part. It'll usually like be descriptive. It's an MCQ likely question, so I don't know what proof columns are for geometry. Yo, Joshua. Okay. Proportional to the square of x. Pretty easy. Easy. Jumping to... No, too far. I need to go over the... There. This is a good formula to have. Not this. Have it memorized. If dy over dx is equal to ky, you can automatically assume that y equals de, where d is some constant. You can leave it as d for now. To the power of kx. So, know this formula. So, dy over dx is equal to ky. Y is equal to de to the power of kx. You could use differential equations to solve it, or you could just memorize it because it comes up very frequently. Yes, this is for Calc BC, yes. Hamlin, okay, I don't know. Maybe we are, okay. Okay, let me cover. Okay, anyway, keep going. Logistic. We learned this. Do know this. This is a memorized type of thing you should know. Logistic growth does come up, and it's a lot to it. You got like several constants. You got dy over dx is equal to ky times L minus y. Rearrange it. Is this AP? Yeah, it basically is. I don't know what that is. Okay. You can rearrange it and have it ky times 1 minus y over L. L is your carrying capacity, which is the top asymptote of your logistic. If you want to solve for it, I wouldn't recommend actually solving it on the exam day, but you would get... I have not done a B test. You get y equals L divided by 1 plus be to negative kx. Your k is the same. B is another constant. And, yeah, k is a constant, b is another constant, and yeah, that's how you would rearrange it. So, do keep this in mind. Times L divided by L. Okay, you could take the L out, okay. And the other is just understanding what each constant is. Carrying capacity, a constant, another constant. Solving, no need to. Actually, hold on. Let me see this. Oh, you probably do need to know that. It's fine. You're fine. It's fine. Unit 7, free low. Unit 8. Oh yeah, logistic is for BC only. BC only. Yes, logistic is BC only. Sorry, forgot to mention that. I believe it is, right? Yeah, logistic equations should be a BC only content. Exponential or whatever this one's called. Hold on. For directly proportional to the y might be an AP con. I'm not sure. I know logistic is BC. Study most integral derivative rules. Know them inside out. Hold on, did I go over everything? Oh, I didn't go over derivatives of inverse. I guess I should pull that up. That's for unit 3. You skipped the topic. Oh, shoot, I said I would at 420, didn't I? Oh, I'm cooked. Yo, I'm moving way slower than I should. Okay. Let me quickly go over derivatives of inverse. That should have been a unit 3, but my teacher didn't go over it, so. Okay, let me quickly change my screen. Chrome. Okay, there we go. So, derivative of inverse is 1 over... Okay, so derivative of inverse at some x is equal to 1 divided by derivative of... Okay, no, hold on. Let me rephrase it. Derivative of a function is equal to 1 divided by its derivative of its inverse of the function at x, if that makes sense. Which is kind of weird. Yeah, I know, I'm not the best teacher. And I'm kind of just yapping because I'm trying to squeeze a year's full of content within 3 hours. So yeah, 1 divided by derivative of the original function of the inverse at that point, if that makes sense. Don't worry about this. This is an AB stuff. If you're an AB, review this. If you're not, don't worry about it. Yeah, it's on Facebook. Okay, switching back to OneNote. Okay. Oopsie, what happened? Close. Okay. OneNote. AP Pre-Calc, no, I can't review it. I forgot everything from AP Pre-Calc. I'm sorry. Oh god. I guess I should also review... I'll go back and review that later. The Riemann sum, the integral definition or whatever. Okay. Yeah. Quadruple. No triple, no quadruple derivatives on the test. Area between curves. Easy. Bounds, top minus bottom. You can do it with respect to x or respect to y. You would usually have a calculator for these type of questions unless it's an easy integral. Let's hope there's no with respect to y. Sometimes it's easier because the top changes, as you can see, which is when you want to flip it and deal it with y. In which case you would have -2 to 1. Yo, what? Okay, anyway. Too many comments. Respect to y, respect to x. Sometimes it's easier y, sometimes it's easier x. Rely on x, or rely on y. 3D, volume by cross sections. This one's kind of important. Know your cross sections. If it's a square, it's b squared. If it's a rectangle, it's height times b. Isosceles triangle with a leg of b, or r, however you want to think of it, is 1/2 b squared. Isosceles right triangle with a hypotenuse of b is 1/4 b squared. I'll show how all this applies in a second. Double integral is not on the exam. That's multivariable for Calc 3. Equilateral triangle, side length of b, square root of 3 over 4b squared. Semicircle with diameter of b is pi over 8b squared. These are just something you have to memorize. Or not, you could derive them. It's just I don't know if you're going to have enough time to do that on the exam. How does it apply? S is the base of a solid with cross sections perpendicular to x-axis perpendicular, so it's like vertical. Semicircles, so we use pi over 8 times b. Do not evaluate. I like the BAV format. Perimeter, yes, we do care about it. I am taking the test tomorrow. If it's even, then it's equal to the coefficient fraction. You can literally go to the restroom during AP exam. I've done it during AP Chem. Both sections. Except, try to make it quick. I'll finish the test first and close integrals. Not sure. Yeah, okay. Okay. BAV is a good format. B, you set up your base. Here, we have 6 minus 2x minus whatever your bottom is, which is x, so it's minus 0. That's your base. Your area, which we learned for semicircles, is pi over 8. Parentheses b squared. Your b is 6 minus 2x, so just plug it in. And then your volume is where it's constrained between, which is 0 and 3. So it's integral from 0 to 3. I've done AP Chem. But you can chat amongst yourselves. Okay. Volume is 0 to 3, pi over 8, parentheses 6 minus 2x squared dx. Area of cross-section, dx dy, depending on which one, A to B. Same logic with different cross-sections. If it's perpendicular to the y-axis, make sure to rearrange the equation as needed. Revolutions. Pi r squared is your go-to for this one. Your r is the area between the graphs, between the graph and the x-axis, or the graph and the axis of revolution. Pi r squared, your r is the graph, or not the graph, it's the top minus bottom. That's what your r is. Pi can be moved to the front, or you can keep it in the integral, doesn't matter. Easy stuff. One of the hardest units in AB though, so if you need review, please go and review this, because we're about to jump into series after this. The amount needed for a 5 on AP Calc BC is 70-ish out of 108 points, depending on the curve. Washer disk method. Remember, for washer, it's r squared minus little r squared, not r minus r squared, because that's not how algebra works. You'd revolve this r and then this r. It looks something like this. You put pi in front of both of them, but you can just take the pi out to the front. So it'd be f of x minus axis of revolution squared minus this one minus axis of revolution squared. And then your axis is 2 and 6. So know your washer method. Does anyone need help with the washer method? Hold on. Composite score is 108. Not sure why. Series was the easiest unit in calc. That's so true. I feel like I'm exhausting my throat too much. We might show a little bit after the stream is over. Easy stuff, easy stuff, easy stuff. Arc length. Know this formula. I'll let you guys look at it. Respect x, respect y. It's square root of 1 plus y prime squared dx. Or square root of 1 plus x prime dy. Your bounds are where you want to find the arc length to from. So hardest unit for AB. I'd say unit 8, the one I'm going over right now. Which is why I suggest to go and review it on your own if you want more in depth. Most of it is pretty easy, but it takes some time to like visually understanding what is going on. I am really tired. Okay. No, I'll get through. I'll get through BC content. I'll get through. Then I'll end the stream. I'm getting super tired though. That is true. Okay. Take derivative of it. Easy stuff. 1 plus derivative of that squared dx or dy depends. One can be done by hand. The other one not so much. That's when you want to change it between dy and dx. Probably chemical engineering. Midpoint Riemann sum example. God. Okay. Midpoint Riemann sum example is not that bad. Just you have to. Okay, fine. I'll just bring up the example. Yeah, honestly, I'm just gonna stop reading the chat. Okay. Are we done with unit 8? Yeah, we're done with unit 8. let's get to series. So series, sequence, ordered number of, it's just an ordered list of numbers. Series is a sum, a sequence is an ordered list of numbers. Series is a sum of a sequence. Infinite series, sum of infinite number of terms. Infinite series, sum of infinite, kind of implied. Sigma notation, start, end. Math, you have this option, you might not need it. Convergence, divergence. If it converges, it equals to a number. If it diverges, it does not equal to a number. That easy. Examples. There we go. I'll cover them later. Nth term. Test for divergence cannot conclude convergence. Limit as n approaches infinity of a term. That should be your first test you should jump to. If it equals 0, move on. If it doesn't, you know it diverges. It proves divergence, not convergence. Examples. Most of it is limits. If you know how to do your limits and FEPL, it goes back to unit 1 as I said. FEPL, what matters most, hospital. Use them as needed. Geometric series. It's usually in the format of a times r to the n. If your r, absolute value of it by the way, is less than 1, converges. If it's 1 or greater than 1, it diverges. To find another thing, one of the few series which you can actually find what it converges to by taking initial term over 1 minus r. Your r is this. Initial term, let's see, it starts at 0, plug in 0, 24, 24 over 1 minus 0.25 is converges. We know it converges because this is less than 1, absolute value of this. And this is what it converges to. P series. Oh, hey Siri. Okay. A constant over n to the p, where p is a constant, an exponent. And it has to be greater than 0. Now, yeah, that's a format of a p series. P series test. We look only at the constant of p. If p is 1 or less than 1, it diverges. If it's greater than 1, it converges. Key thing, p of 1 is actually a divergent harmonic. Harmonic. You can literally say harmonic on the test and get points. Geometric versus p series. Make sure you know your algebra. Here the n is exponent. That's what gives it away that it's geometric, most likely. Here the 3 is in the exponent, so it's a p series. Integral test. You can turn your series into an integral, and as long as f of x, which is your f of n, or a of n almost, is continuous, positive, and decreasing eventually, the integral and the sum behave similarly. So either both converge or diverge. Eventually means that at some endpoint far along the graph as infinity, as a limit as n or x approaches infinity. It considers it has to be continuous, positive, decreasing eventually. Integral converges, then the series converges. Integral diverges, series diverges. Keynote, value of integral is not the same as value of the series. As a matter of fact, the value of the integral is less than the value of the series. That may come up as an MCQ question. I've seen it come up before. Value of the integral is less than the value of the series. Easy. Key thing. Where I said about improper integrals, right? Yeah. We don't want any of that. Where is it? Okay, didn't put an example. We don't want any of that bar and 0 infinity. That's going to lose you points, especially on FRQ. Put limits and evaluate them accordingly. Direct comparison test. This one's kind of tough in terms of explaining, but you should probably already know it. I'm going to put my phone away, actually. You're comparing a given series to a simple series. If the given series is less than a convergent, then the given series converges, obviously, right? If some series converges and the terms are less than that series, it's going to converge also. If the given is greater than the divergent, then it's going to diverge, right? If that one diverges, but these terms are bigger than the divergent, then obviously it's going to diverge as well. If the given is greater than convergent, we can't assume it converges as well or diverges. We just have no info. If the given is less than diverges, we don't know if it diverges or converges, so no info. That's when we rely on limit comparison test. Simple over given or given over simple, it doesn't matter. Same ratio-ish. Limit is finite and positive. Both behave similarly. The given and the simple that you're comparing it to. If the limit is negative, does not exist, positive or negative infinity, zeros, stuff like that, no info, rely on ratio test, which we will cover in a second. But first, alternating series. This one's a big one. You want to check all three conditions on the test. Terms have to alternate, limit has to approach 0 of a of n, and terms decrease in absolute value, which can be written in one of these two ways on the exam. A of n decreases as n increases is one way. That's the one I rely on, this one. Oopsie. Oh, God. Oopsie. My name was... Yeah, I know. I noticed. Okay. Yo, what is going on in chat? Yo, okay. Anyway, okay. Converges by AST. No info. Okay. So, if the terms don't alternate sign, terms have to alternate sign. That's one of the conditions. Use a different test, which should be pretty obvious. Limit does not equal 0. Nth term means diverges. And if the terms don't decrease in absolute value, we have to try a different test. All three are true, converges by AST. Absolute conditional. So absolute convergence is when A of n, series with A of n, and series with absolute value of A of n both converge. Conditionally, a series converges conditionally if A of n converges but absolute value of it diverges. Alternate harmonic conditionally converges. You can just assume that. Grandi diverges, which is this. This is Grandi. If you see this, it's Grandi. It diverges. This is harmonic, diverges. Alternate harmonic conditionally converges. Alternating error. Oh god, this is going to be tough. If you come across an alternating series and you're looking for an error bound, it converges to some sum. If we approximate that sum, we could say sum minus approximation of the sum is less than or equal to the first omitted term. I'm not going to go over examples, but you can look at this work. Ratio test. You need to know limits, powers, factorials. For a ratio test, it comes everything appears in ratio test. Limit as n approaches infinity, absolute value of a of n plus 1 over a of n. If the limit is less than 1, it converges. Absolutely. Oh, I did not know that. I guess that makes sense, actually. If limit is greater than 1, or does not exist, it diverges. If limit is equal to 1, then no info. Root test. It is not part of official BC curriculum, but if you want it, here's some info. Power series. Power series are in form of an times x minus center to this exponent in terms of n. Formula for coefficient in terms of n. Can be finite, can be infinite. Centered at 5, because x minus 5. Plug in your x to see if it converges. You could use ratio test or geometric series test to determine radius of convergence. This is the nice form, x minus c less than r. Got the interval of convergence. Interval is 3, right? Starts at 5, 3 this way, 3 that way. Could be inclusive, exclusive, or a little bit of both. Radius is a number. Always converges if the radius is infinite. Converges at point. Only one point if the radius is 0. Here are examples of each. Yeah, okay. Taylor polynomials. Pattern. Doesn't matter. Actually, I'll leave the pattern. Maybe some of you would need it. Table method is effective. Nth derivative. Evaluated at c that derivative. F of n c over n factorial times x minus c to the n. You could use p and whatever degree it is, x, to show your Maclaurin or Taylor polynomials. You could also use t instead of p. The big five, you gotta get these memorized. I'm gonna leave them here. Memorize these. Okay. So let me look over the natural log of x one. Yeah. This is just proofs. You don't need their proofs if you memorize them. Oh. Yeah, this is modifying this series. Square root of x, plug it into the x, do some algebra, find your new series. Plug in your x for natural log of x, multiply by x squared, so distribute that to every term. You can easily find your new series, basically. Maclaurin series. Work backwards. Look at the factorials. They take priority because you can't really edit factorials that easily as you can with the x values. I don't know, is anyone still watching? I don't even know if anyone's still watching. I don't know, I'm gonna quickly make sure people are still with us. Okay, anyway, yes, so it's not bad. It's just you substitute in, you gotta know your algebra, you gotta recognize it's one of the big five, and then yeah. Derivative. This is too hard. I don't feel like explaining it, so I'm just gonna leave it here. It makes sense, trust. Relate it back to the Taylor format, and you'll be just fine. Okay, there's just example problems if you really... Oh my god. That is a... Yeah, okay. Lagrange. Let's get to it. Naturally, you'd use alternating series bound, which I already covered, for sine of x, cosine of x, natural log of x, because they're alternating series. Remainder, this one is for e to the x and other series. Yeah, okay. Complicated. I'll get to the easy part. The whole idea of the formula... Wait, where did it? There we go. Don't worry about the graph. Error, which you can just do, absolute value of error, is less than or equal to x, which is where you're approximating at, minus the center, absolute value, to the power of n plus 1. So the next one, just like alternating series, you take the next one, the next degree, divided by n plus 1 factorial, so the next one, times the maximum value of absolute value of the next derivative. May seem complex, but here's a practice problem. At x equals 1, we know our center. Identify as many knowns as possible. Okay, first of all, this is unlikely to show up on the FRQ this year. It might be like an MCQ or something. If it's an FRQ part, I would be kind of disappointed, but then again, it's pretty easy. You're approximating the maximum value of the derivative between x and c. Our c is 1. No, our c is 1. Our x is 1/2. 1/2 minus 1, absolute value to the 4th. because we're using third. We're taking the next one, 3 plus 1. 3 plus 1 factorial at the bottom times maximum value. Zoom in on the graph of the next derivative, the fourth one. That's what we want. On this interval, you can see the maximum possible value is 30. Sure, you could argue, oh, it's like 28 or 29 or something. Let's just go with 30 for security measures. This way you could prove that the error is less than 1 over 12. That's it. That's all there is to series. Know all your tests. Know your big five. Know alternate series error. Know your Lagrange error bound. I'm still in high school. I have my exam tomorrow. Okay, polar. Oh god, my name's back. Yo. Jump scare. My name jump scare. Okay. Give any questions for X and Y in terms of priority. AP Fortnite, you, I'm cooked. My brain is beyond cooked. What about you? Euler proofs. What I'm gonna get cooked on? Silly mistakes. Being too tired tomorrow, that's what. Given equations of X and Y, parametric, kind of easy. Literally, if you took pre-calc, you know all of this. Beginning, you know. It has, parametric has, what does it have? Direction, right? Eliminate the parameter, you lose your direction. Derivatives. dx dt greater than 0 goes right. dy dt less than 0 down. Easy peasy. dx dt dy dt. dy over dy dx is dy dt over dx dt, slope of the tangent line of the parametric. You guys know all of this. Second derivative, a bit tricky. Here's the formula. Take derivative of dy dx again and put it over dx dt. Concavity, just interpret your second derivative. Yep. Actually, I'll leave this one. This is a good summary. Arc length. Same as what I already talked about. Review. For parametric, bit different. You got your two t's bounds. You got your dx dt squared plus dy dt squared, square root integral. Parametric with PVA. Interpret where it's moving, plug into dy dt. Position, use your first fundamental theorem of calculus. Actually, I'll let you, I'll zoom out so you can actually see. Particles velocity, vector and acceleration vector. Substitute your values, take derivative for acceleration of each individually. Speed is absolute value of velocity. So magnitude of velocity. Take square root of dx dt squared plus dy dt squared. Should get your speed. Oopsie. One more example. For total distance is the integral of velocity. No. Total distance is the integral of absolute value of the velocity, which is speed. Rectangular coordinates. Yeah. Just know how to convert it. Know this. Yes, several ways to write a polar coordinate, polar to rectangular. Use some algebra and conversions that you should have memorized. I'm gonna leave this on here. Find period. The period of tangent is pi. Pi divided by 2 is your new period. So, yes, find what your theta is, and then add your period until to find every single point within the bound. Tangents, important theorem, kind of implied. If theta equals k is the solution to r equals theta, I mean, oh my god, r equals 0. Then the line theta equals k is tangent at the pole. Easy. Find intersections. Set them equal to each other, find your thetas. Set both of them individually equal to 0 and see if some theta exists, meaning they touch at the pole. dr d theta is not the same as dy dx. To find dy dx, similar approach as with parametric. I'll zoom out if you guys want to do the practice problem. Area. In radians, area of a sector is 1/2 theta r squared. Area of a region in polar, r cannot change signs on the interval, so you gotta split the integral if r begins to change signs. We like symmetry, we want the two angles to be close to each other, and we often split the integral into multiple integrals. Example problem: 1/2 integral of r squared d theta, which follows the same logic as area of a sector. 1/2 integral, 1/2 is a constant, integral of r squared d theta. Theta turns into d theta, if that helps you think of it. Rows with petals, inner loops, common interior practice problem. That's all. That's it. That's all you need to know for calc. Okay, well, I didn't cover like one concept, but I'm about to pull it up. There's a lot of good sources out there to explain this, maybe better than I do, but here's the Riemann summation notation, which might be like one question tomorrow. It's really complicated, but the idea is that you're using these two bounds to approximate the integral using a limit of Riemann sums. The another form I have is let's see, this picture maybe. They're both equally used. Actually, no, there's an example problem here. Rewrite definite integral. So it's going to be 4 over n, that's your dx, that's what delta x, because 6 minus 2 over n, times f of a. It becomes the sum of f of a plus I delta x. For this one, we're not going to be using I, we're going to be using k. So plug in a. Our a is 2, that's our lower bound. A plus delta x times k. K is whatever the Riemann sum is going through. It gets updated. Squared, that's what our f of x is. Minus 3. So it's only our x that changes. And yeah, those other questions that have been shown are a little bit trickier, but honestly, I'm just gonna wing it. Screw it. Going for a perfect score? It's not on the exam, trust. Here's another good picture. This is a bit different, actually. It starts at 0 and minus 1. Yeah, this is a bit different. Okay. Anyway. I'm gonna read the chat and then I'm probably gonna end the stream. Okay, I think we're gonna end the stream here. It's been 3 hours. Okay. Thank you for watching. Hopefully you guys are ready for tomorrow. I'm sure you are. You'll do just fine. How do you know if you got a perfect score? You get an email in early fall. Or even December. I don't even know when you get the email. You get an email. I know that for a fact. Okay. I'm gonna end it here. See, guys, I'm so tired right now. I'll probably do a little bit more review and then call it a day. We'll be fine. Good luck. AB, BC, pre-calc students, you got this. And even all the people taking other AP exams next week, yeah, you'll do great.